welcome. I can't do this right now, I feel too silly. This is a introduction to the free educational film called The Evidence. And hopefully it'll provide you with some evidence that there's a better life to be had for us as a human species, for us as individuals, and that through the understanding of mathematics, physics, and biology, we can optimize the natural capabilities that are imbued in us simply because we exist as human beings, simply because we exhibit a consciousness. So hopefully what this film will provide you with is the capacity
Cut.
Take two.
Welcome! This is an introduction to the free educational film called The Evidence. The evidence for what? Well, in a general sense, the evidence that there's a better life to be had.
And that the path to getting to this better life includes understanding mathematics, understanding physics, understanding biology, and internalizing and actualizing these things in our day-to-day life. In this film, we go through a dynamic process of looking through a lot of different fields of science. We start off with looking at mathematics and what the process of mathematics is and what mathematics means. And then concurrently with that, we start looking at some of the mechanics of consciousness. Every human being integrates and produces data in a unique way, but also that there's this sliding scale between completely ordered and completely disordered. There's this sweet spot that utilizes all these different phase spaces in order to be optimal and to be conscious. And that's literally how we have self-conscious. If we're overly ordered, there's sickness and illness there. If we're overly disordered, there's sickness and illness there. There's the sweet spot in between. And the sweet spot is an area that includes empathy, intelligence, and understanding. And these things are described in the film through mathematics, physics, and biology. The three key concepts here are mathematical understanding. Mathematical understanding isn't just it's beyond calculation. We look at what calculation can do and how calculation exists everywhere in the universe, but also how what we're doing with understanding and even mathematical understanding is different than calculation itself. I don't want to give too many spoilers away because I want I want you to review the evidence and to come up with your own ideas given the current latest and greatest of what we got going on as a species. But I think even on the simplest level, even if you're not a mathematician or a physicist or even into those things, you can really resonate with the biological research that's presented in this film. Every person has the capacity to have a micro moment of shared positivity with another person. And this isn't just a moral thing or a good thing. It's literally what we're designed for biologically, and it optimizes our capacity to receive insight, to overcome problems, to regulate our health and wellness, and even our biochemistry. And so, and towards the end of the film, we start getting into, human dynamics and social dynamics. And also, at the very end, you're presented with a little bit of financial and technology ideas that can help, I think, when used with the understanding of mathematics, physics, and biological functioning, we can get a clear framework of where to go with all this. Pretty soon here, I'm gonna go through the film again and give a little bit of, I'm gonna give a little presentation on what I think the end game looks like. What does it look like if we put into play what we know about mathematics, physics, biology, and finance, and all the latest and greatest of what we got? What happens if we actually all knew that and all use that for our capacity to grow as a human being and as a human race and as family, as a society, and all that? So please review the evidence for yourself, whether you watch it all in one sitting or it takes you a week to watch it or a month to watch it. One thing I can guarantee is that you'll be a better person because you looked at it. You will, there's going to be, you get to hear from a lot of different people, and I promise you there's going to be something said by one of them that means something to your life and that you're going to be able to utilize in a meaningful way that makes you a better person. That's why I made this little film, is so that no matter who watches it, what background, whether they're upper echelon or can barely understand the spoken English language, you will be able to get something from this, even if you're not a scientist or a mathematician. So without further ado, please go on and check out the film. Thank you so much. Peace.
Of what's true in mathematics is not governed by rules. And whatever rules you lay down, you can always transcend those rules. If you accept the rules, you can see how to go beyond them. And this is amazing. It's really hard to see this. You could say, okay, maybe all we do is believe these axioms and these rules, and that's all we do. And then Gödel says, no, you have to believe this too. If you believe those rules, you must believe this other thing, which is beyond the rules. So what's going on, you see? If it was, and this rules, Turing, in his idea of a computing machine, showed, idealized what rules mean and what it is to follow a computation. And this is a way, somehow it shows that the mind, in our understanding, whatever understanding means, is not something you can encapsulate in a computation. So this idea had been with me for many years. The statement here is that the perception of mathematical truth cannot be reduced to a set of mechanical rules. And this comes from a famous theorem due to Gödel, and Turing was certainly very familiar with this. It featured very much in his 1936 paper, the original one, because he was very much concerned with things that computers couldn't do, if you like. That was part of what he was trying to do. And so as to say what you couldn't do by a mechanical procedure, he had to define what he meant by a mechanical procedure and then show that there were certain things that you can't do with a mechanical procedure. Well, I'm going to phrase Gödel's theorem in a way which it's not normally phrased, but it is a perfectly correct deduction from his theorem. Tells us that for any mathematical theorem, and that's the kind of thing I'm talking about here with natural numbers and so on, it tells us for any set of mechanical theorem-proving rules, and when I say mechanical theorem-proving rules, I mean you have a set of procedures which can be checked by a computer. That's the crucial point. If you follow these rules and you come to a conclusion that it proves some mathematical statement of the kind we're talking about, then that alleged proof can be checked by a computer. So that's the kind of rules we're talking about. Then what you can construct is a particular mathematical statement, which Gödel shows you how to do, and I'm calling that G of R, which if we trust the rules, if we believe in the validity of the rules, that is to say, if we believe that anything we derive using the rules must be true, if you trust the rules, then you must also believe that this particular statement, G of R, is true. Yet, it cannot be proved using the rules. Now that's a very striking, remarkable thing, because what it's telling us is that whatever these rules are, if they're rules whose consequences we believe in, then that belief or that trust extends beyond the rules themselves. And you have to know that the rules are trustworthy, and that belief that they're trustworthy enables you to extend beyond the rules. So that this particular statement, G of R, cannot be proved using the rules of R, but the way in which it's constructed tells you that it's nevertheless believe it's true. See, people usually state Gödel's theorem in a rather negative way. They say there are certain things you can't prove. But what they mean is you can't prove using a very specific set of rules. But if you trust those rules, then you can see that statement is true. And this is a very striking thing about the Gödel statement. And clearly Turing was very much aware of this. And
the word mathematics originally comes from this Greek expression, ta mathemata. Ta mathemata means things we gain by taking. But it's not the taking in the ordinary sense. It's the taking of what we already have. So we usually take something that we don't have, but ta mathemata means things we gain by taking, but the taking is the taking of what we already have. Well, this is difficult. In other words, mathematics in its original sense means the taking of what you already have and the knowing of what you already know. So what does that mean? There's a Japanese mathematician called Okakiyoshi, and I hope everyone will remember this name after this presentation. He used to be in Kyoto, and he's one of the world's most known Japanese mathematician. And Oka was actually so great that some people in Europe thought that Oka was a name of a group. They couldn't believe that he did all this job by himself. Just one single person did all this job. They couldn't believe it. And Oka was not just a great mathematician, but he was also a profound thinker and philosopher. He has left some great quotes and beautiful essays on the nature of mathematics. And in particular, he repeatedly said that mathematics can say nothing of the first number 1. Well, obviously, numbers are the most simplest objects in mathematics. But if you try to explain why the first number 1 has to exist, or what the first number 1 is in the first place, no matter how hard you try, mathematically or logically, you will never be able to explain or never be able to prove the existence of the number 1 or what the first number 1 is. We simply believe it. It's the believing of something with no grounds. Without this power of our mind of believing things, math will be totally groundless and meaningless. So at first sight, math seems to be about numbers and calculation and logic and all that stuff. But underlying calculation and logic, there's this huge dimension in our minds that underlies all calculation and logic. So at the heart of mathematics, there's not numbers, there's not logic, there's not calculation, but there's this huge dimension, our inner universe, which Okakiyoshi called Jocho. And Jocho is a difficult Japanese word. I was looking for a good translation for it, a good English word that corresponds to Jocho, but unfortunately I wasn't able to find one. So let's just call this Jocho. Jocho. So in Oka's terms, math is not about numbers, math is not about calculation, math is not about logic, math is about Jocho. It's the very act of looking inside your mind and, well, encountering with your own self, encountering with your own rich inner universe, your Jocho. So if you want to do mathematics, pick up a problem. It doesn't have to be a difficult one. You don't even have to prove a theorem that no one has proved yet. Just pick up a problem, it can be an easy one, and concentrate on it. Try to solve it yourself. Don't look at the answers, don't cheat. Keep on thinking about a problem until you figure your way out by yourself. Then, so you have to be patient, you have to keep on paying attention. Being patient and keeping attention on one subject is very important. And during this mindfulness, you'll find yourself encountering with your own mind. And if you're lucky enough, you'll find yourself swimming around in the sea of Jocho inside your mind. Well, try it if you have time. So this was a very short presentation on mathematics, and basically I only have one message. Math is not about numbers. Math is not just about calculation. Math is not just about logic. Math is the very act of looking inside your mind and encountering with your inner selves, with your inner universe, with your inner rich whole dimension of Jocho. So in this sense, everybody, including you, can be a mathematician. Thank you very much.
Explorations in the computational universe, I came up with a hypothesis that I call the principle of computational equivalence. So let me explain it a bit. When we have a system like Rule 30, or like the system here, like something in nature, we can think of it as doing a computation. In effect, we feed in some input at the beginning, then it grinds around, and eventually out comes some output. Then the question is, how sophisticated is that computation? Well, we might have thought that as we make the underlying rules for a system more complicated, the computations it ends up doing would somehow be progressively more sophisticated. But here's the big claim of the principle of computational equivalence, that that isn't true. Instead, after one passes a pretty low threshold, and one has a system that isn't obviously simple in its behavior, one immediately ends up with a system that's doing a computation that's as sophisticated as anything. So what that means is that all these different systems, whether it's Rule 30 or whether it's a fancy computer or a brain, they're all effectively just doing computations that have the same level of sophistication. Well, okay, so there's an immediate prediction then from the principle of computational equivalence. There's this idea of universal computation. It's really the idea that launched the whole computer revolution due to Alan Turing and friends. You might have thought that any time you want to do a different kind of computation, you need a different system, completely different system. But the point of universal computation is that you can have a single universal machine that can be programmed to do any kind of computation. And that's what makes software possible, and that's the foundation for essentially all computer technology today. But okay, the principle of computational equivalence has many implications, but one of them relates to universal computation. It says that not only is it possible to construct a universal computer, but actually it's easy. In fact, pretty much any system whose behavior isn't obviously simple will manage to do universal computation. Well, one can test that. Just look, for example, at these simple programs like Rule 30 and see if they're universal. We don't yet know about Rule 30 in particular, but we do know, for example, that a program very much like it, Rule 110, is universal. A few years ago, we found that even among Turing machines, the very simplest one that shows not obviously simple behavior, but still has a very simple rule, is also universal. Now, we might have thought that to build something as sophisticated as a universal computer, we'd have to build up all kinds of stuff. We'd, in effect, have to have this whole civilization that figures out all of these different kinds of things. But actually, what the principle of computational equivalence says, and what we found out is true, is that actually out there in the computational universe, it's really easy to find universal computation. It's not a rare and special thing, it's ubiquitous. And for example, it'd be easy to mine from the computational universe, say for the particular case of practical importance of making molecular computers or something. Well, okay, the principle of computational equivalence has other implications too that are pretty important. One of them is what I call computational irreducibility. See, a big idea of traditional exact science is that the systems we see in nature are computationally reducible. We look at those systems, say an idealized Earth orbiting an idealized sun, and we can, with sort of all our mathematical and calculational prowess, we can immediately predict what those systems are going to do. We don't have to trace every orbit, say. We can just plug a number into a formula and immediately get a result, using the fact that the system itself is computationally reducible. Well, it turns out that in the computational universe, one finds that lots of systems aren't computationally reducible. Instead, they're irreducible. There's no way to work out what they will do in any reduced way. There's no choice but just to trace each step and see what happens. It's actually pretty easy to see why this has to happen, given the principle of computational equivalence. We've always had kind of an idealization in science that systems we study are somehow computationally much simpler than us as observers that study them. But now the principle of computational equivalence says that that isn't true, because it says that a little system like Rule 30 can be just as computationally sophisticated as us with our brains and computers and so on. And that's why it's computationally irreducible, and by the way, also why its behavior seems to us so complex. Well, computational irreducibility has all sorts of implications for the limits of science and knowledge. At a practical level, it makes it clear how important simulation is and how important it is to have sort of the simplest possible models for things. And at, for example, a philosophical level, I think it finally gives us an explanation for how there can be both free will and determinism. Things are determined, but to figure them out requires an irreducibly large computation. But okay, so the principle of computational equivalence has another implication that relates to intelligence. There are various concepts, like life, for example, that always seem a bit elusive. I mean, it's pretty easy to tell what's alive and what's not here on Earth. But all life shares a common history here and has all sorts of detailed features in common, like cell membranes and RNA and so on. But what's the abstract definition of life? Well, there are various candidates, but realistically they all fail. And either we have to fall back on the shared history definition, or we have to just say, in effect, that what we need is a certain degree of computational sophistication. Same thing with intelligence. We sort of know historically what human-like intelligence is about, and we don't have a clear abstract, but we don't have a clear abstract definition sort of independent of that history, and I think ultimately there just isn't one. In fact, it's sort of a consequence of the principle of computational equivalence that we can't make one, and that all sorts of systems are ultimately equivalent in this way. I mean, you know, there are expressions like, the weather has a mind of its own. And one might have thought that that was just some very primitive, animistic point of view of the world. But what the principle of computational equivalence suggests is that, in fact, there is a fundamental equivalence between what's going on in, for example, the fluid turbulence in the atmosphere and things like the pattern of neuron firings in our brains. And you know, this...
But does randomness actually save free will? And many people have chatted about this, okay? My claim is that actually this question about determinism and randomness, which goes in philosophy under compatibilism and incompatibilism, really doesn't have much to do with free will. What is free will? Or rather, not free will in general, sorry. This sensation, our inability to predict our own actions and our own decisions. Let me just talk about that. Where does that come from? Well, I mean, as was pointed out by Marcelo, that you know, now we've got these neuroscientists, poke around in our brain, know what we're going to decide like a few minutes or a few seconds before we do it. So they go walk around saying, hey, we don't have free will. Actually, Stephen Hawking says this as well in one of his books. I had a good Hawking quote about this. Completely wrong. Here's a poor brain. I mean, come on, a poor brain, all right? So why is this not true? I claim that the origins of our inability to predict ourselves lie in the halting problem. Here is a Turing machine. The Turing machine is simulating itself, simulating itself, simulating itself all the way down the line, like, and you know, what the heck is that? So, the halting problem, what is the halting problem? If we have a Turing machine and it starts to ask itself questions, it says, will I ever be able to answer the question of whether I'll be able to answer the question, I wonder what the answer is. And I claim, and I will give some strong evidence, and in fact some mathematical theorems. I will not show you the theorems, but basically this result gives a mathematical theorem that proves that, that shows that this is the basis for our inability to decide what's going on. So in fact, if you have finite resources, so Turing halting problems comes from having infinite resources. Let's look at finite resources. Here's a rather attractive, I believe, woman contemplating modeling herself, thinking about herself, thinking about what she's going to do. And you see, just to be able to draw this in 2 dimensions, I had to make the things in the thought bubbles less detailed than the woman herself. And that's because if you try to model yourself, your models will be less detailed than you are yourself. And there's a very nice set of theorems from computer science that capture this beautifully that says that simulating yourself is either slower, less detailed, chancier, or all of the above than actually being yourself. And the nice computer science version of this is called the Hartman-Stearns theorem, a beautiful, Scott will tell you, beautiful theorem from computer science from 1961 or sometime like that, which says that to predict with certainty what you will decide to do an hour from now takes more than an hour. It takes more computational resources because asking the question yourself, gee, what am I going to be doing in an hour is like a lot slower than just doing it, okay? So, and this is true, okay? So sometimes any system that can actually contemplate, ask itself the question, what am I going to do in an hour, often won't be able to answer that. This is true whether the universe is deterministic or probabilistic, irregular, chaotic, classical, quantum mechanical. These are my like kind of Keith Haring-like pictures of a quantum thing with like little Sorry. And so I'd like to propose, and by the way, this is I have a paper on this published in the Philosophical Transactions of the Royal Society, where all the theorems and everything are presented in gory detail. It's called A Turing Test for Free Will. You'll find it on the archive. There was a good Slashdot conversation about this a month ago. A Turing Test for Free Will. So let's like ask these questions. This is a self-administered test, right? Because like unlike the real Turing test, you know, you should give it to yourself, because if you cheat, you have only yourself to blame. Who are you hurting? Just you yourself, okay? Are you a decider? So are you making a decision? Can you model your behavior and maybe that of other things around you? And then the last one is, can I predict my own decisions? And that, of course, is a trick question because, you won't be able to do this. If you answer the first two questions correctly, you cannot do the third. This is just a mathematical theorem about anything that is trying to predict itself. And let me give it as an example, George.
That's certain. So I can't see how this very sophisticated, very precise, unknown, unknowable algorithm can have come about through natural selection. So I leave you with that challenge. And it seems to me it's a big challenge. So what's been going on then? What was selected for if it was not a complicated, unknowable algorithm for doing things, arithmetical problems, which I can't believe? What it was, I think, is consciousness. You see, I would argue that consciousness, well, you see, it has many manifestations. Passive things, qualia, perception of the color red, or appreciation of a melody, or so forth, or active, free will, all these things. All sorts of words here which have to do with consciousness in one way or another: pain, love, red, pride, determination, intelligence, disgust, etc., etc. I want to concentrate on one word, that's understanding. And also only understanding in a very specific context, namely the one which you use to derive the validity of G of R and the fact that it can't be derived from R. In fact, I'm going to give you this argument later on, so wait for it. That's the hardest part of what I'm going to say, but I'll give you the argument. So it's not something which is that difficult. I'll give it in outline. And the basic point is understanding of what you're doing. And you can't, it seems to me, formalize understanding in terms of a purely computational system. And here is issue, I say, is a computer-controlled robot capable of genuine understanding? Well, this sort of question has come up here. And whether you could test for understanding is one question, and that relates to the Turing test. Say, can you ask your computer or person, whichever it is, a question which requires understanding in the response, and that's the sort of thing that computers tend to lack. In fact, you see, I would say that how do we use computers in most things? If you want to solve some, or simulate some problem about how stars behave or something, and you have a calculation you want to perform to see what it's going to do. Well, you supply the understanding, the computer does the calculation. It's a symbiotic relation we have with computers. That's fine. I have no problem with that. But it does seem to me, okay, the answer that the computer produces, it hasn't the remotest idea what it is, what it's for. You have to supply the understanding. So it seems to me the understanding is what the computer doesn't have. And now I've had three words here. I'm not going to define understanding. I don't know how to define understanding. The three other words I don't know how to define either. Intelligence is one of them, and awareness is another. All I'm saying is that they seem to depend, at least intelligence, whatever it is, I would think depends on understanding, because I wouldn't like to say of an entity that it is intelligent if it doesn't possess understanding. That certainly seems to me a natural use of words. Likewise, I would hesitate to say that an entity possesses understanding if it does not possess awareness. So it is related to this consciousness issue. Awareness is an aspect of consciousness, so it seems to me so is understanding. This doesn't say that computers couldn't have it. It's just saying that they're interrelated in this kind of way. So if understanding can be shown to be beyond computation, and that's the sort of argument I've just been trying to present you with, then intelligence is not a matter of computation. Moreover, certain aspects of awareness, and perhaps all, are beyond computation also. So that's my position here, is that these things are beyond computation. Now I want to get slightly more technical, and I hope you'll bear with me here.
Now, a general principle which may explain all of this stuff is the metric of entropy, or the measure of order or disorder. So the idea I want to submit is that on this kind of dimension of entropy, this sort of dimension of order, essentially, there's a kind of sweet spot. So these are ideas that are talked about a lot at the moment in cognitive neuroscience and systems neuroscience. There's a kind of perfect place. There's a perfect balance between kind of formlessness or complete disorder and complete stability, but stability to the extent, or order to the extent, that the system then becomes inflexible. So for consciousness to be poised in this kind of optimal place where we can scrutinize the world in the best way, learn the the nature of the world in the most optimal way, and yet retain flexibility given that the world is changeable, then there's a kind of sweet spot where the system has to be, where it's perfectly balanced between disorder and order. And so this would be normal waking consciousness. So I'm sure you probably all guessed where the psychedelic state might be on this trajectory, and it's over to the left. So some states which share a phenomenology with a psychedelic state, which probably also show this sort of increase in disorder in the parameters that define the activity which underlies the states. REM sleep dreaming, early psychosis, the sensory deprived state, deep meditatory states such as this non-dual awareness, the near-death experience, and the psychedelic state. So states which may kind of veer to the right and become too stable, too rigid, so that the kind of flexible quality of consciousness is lost, would be seizure, for instance. So people tend to think of that as a chaotic state, but that's misleading. It's not chaotic. There's very synchronous activity in the brain in seizure, so it is a too organized state. There's too much order to such an extent that there's no flexibility and one loses consciousness. Sedation, again, a very highly synchronous state, deep sleep, and depression is probably over on this side as well, a too fixed, a too ordered state. So this should give you a feel for kind of how brain activity maps onto different conscious states.
So just to finish up, it's this idea of, this is a whole other book, this guy Modell talks about imagination and the meaningful brain. So it's a kind of an intense book, but I thought it was very interesting. And he's talking about this limbic system and what happens to us in our minds. And he's, what I relate to what he said to what they're talking about ego dominance and things like that, is you freeze your metaphors. You freeze your art, your creativity, because that's where the reimagination, that's the recontextualization, that's where the new possibilities come from. And if that system is stuck, there's wrenches in the gears, then you're unable to do that. So he talks about metaphors as just being like, it's one of the main functions of our brain is to relate different domains. He calls that a metaphor. So relating the domain of my thoughts to my feelings, for example, that's one of the functions of the brain. He says that's a metaphor. And if that's broken, if that's not working right, there's other metaphors of like relating the smell to this thought. All these ideas, you can imagine that's what our brain's doing, is connecting different domains. And if that's broken down, and it's that metaphorical system that creates, just like art, just like this poetry and things like that, this new story, this new understanding. And so he says that, this metaphorical system mostly operates subconsciously. And he uses these examples in his book of all these famous mathematicians and physicists that, like, when they wanted to solve some problem, the key is they think about, okay, I'm going to solve that problem, and then next step, stop thinking about it and let it percolate. Get the mind out of the way, let the subconscious, metaphorical, perhaps it's limbic, let that system work on it, and then spontaneously it will start, and that's what they talk about with this entropic brain function. You get into these other stages of possibilities where like avalanches of networks start happening. Things start coming together in ways that your mind can't keep up with, but that we're actually designed to do those things. All right, go ahead.
So does any of this have anything to do with being in the flow?
I say yes. I say that's,
where is it?
So the flow is like, one example, I don't know if this is just a theory, but, this idea, they're saying that, your mind and stuff is keeping you kind of like in this more control to be able to get along and all this stuff. But when you go more open-minded consciousness, which they're saying is more entropic, more similar to what nature's doing, and like just more free, and then you're in the flow more, you know. In other words, the mind gets out of the way, and then now you're the way that what seems like a chaotic, you know, their first thought is, oh my God, don't go there. You're going to get paranoid. You're going to get, who knows what's going to happen. All these crazy ideas are going to come up. But then it's like, well, what if you come into the flow there? And that's what I'm saying. In the higher self, you can come into the flow, and you can be, you know, very comfortable in such a place.
I heard your talk on Amber Lyon's podcast.
Oh, thank you.
So really enjoyed that. So I have a question about the default mode network.
Yeah.
I've thought of that as like is it the same as like a massive like filtering mechanism? Is there a difference between?
I think it's related to that. That's how I think about it. Like I'm thinking about like, because you know there's this, because you see all the sensory inputs going through it. It seems like, you know. So it seems like a filter, and then you talk about like subliminal and liminal. In other words, like your mind's just even your vision, you know, you're constantly filling in all these gaps. So it's like, where do you fill in the gaps, and what story are you, how are you adjusting what you're seeing, you know? And so it does seem that it is kind of like the filter. And so ideally, like, you know, I think in like the shamanic like tradition is you want like the energy to flow from your heart, like through your mind. So ideally, the filter would be like a crystalline structure that would just be, you know, in the flow. But, you know, if it's not, then yeah, you're going to be blocked all these different ways. So I think it's kind of like that. That's how I think about it too.
It also shows the influence of architecture. Here you have a sort of modular architecture in A, where you have a set of elements which are interconnected, but in a certain way. It turns out this breaks down into individual little consciousnesses, very, very minimal ones with two concepts each, but there is no larger entity at all. So you don't have one big consciousness, you have a lot of small ones. In the middle you have another interesting system, 5 elements, all-to-all connectivity, majority rule, if more than 3, fire, I fire. And in that case, the system is one complex, it forms one entity, but it has only 5 concepts, and they're all elementary concepts. They're one specified by each individual element, and by the way, they're all the same. So there's only one star, if you wish, in the past and in the future. It's a totally trivial system with a minimum value of big phi. So it's minimally conscious, only conscious of one little thing, this and not this. On the right is a system with 5 elements, same logic, but only 3 connections per element, and they are different from each individual element. So we have introduced some differentiation. It's not homogeneous like before. Now suddenly it is still one entity, so it's a complex, but big phi is much higher, it's 10.75, and it has 30 different concepts of elementary and higher order. So now it is like something to be that system, and it's something more interesting than before. It breaks many symmetries. So we assume this is sort of true for many systems if you could analyze them properly. Another obvious consequence is that the consciousness can be graded. You can see here by changing the strength of the connections, which can happen in our brain, from high to medium to very low, you can have one entity with high consciousness, so to speak, another one with much less so, but still one entity, and then it breaks down into sub-entities. We think that happens when you go into sleep, as I'll show you. Another counterintuitive consequence is that a system made of inactive elements that supposedly do nothing, okay, these are copy gates that just do nothing at all, they are all off. These could be neurons that are off, will still generate consciousness of a certain kind. So you don't need to pass messages around or signal. It's an intrinsic property of something that is and has that ability of constraining the past and the future. Another consequence, you can have a very simple system, like a photodiode with memory there, which can actually generate a minimum amount of consciousness. That's actually the smallest amount. We call it really minimally conscious. It is like something to be that photodiode, although it's so trivially low that it doesn't even make much of a difference to talk about it. But it is a minimal distinction. It's this rather than not this. It doesn't matter whether you have a photodiode, a blue detector, or a thermistor. In that case, intrinsically, it just feels like just a little bit and nothing more. An interesting consequence is that the purely feed-forward system disintegrate. It's not a system, according to this theory, so that, in fact, if you take even a very complicated feed-forward system, there's nothing it is like to be that. You can show this because recursively nothing can act back on itself, and therefore there's nothing there. We can use it, but it doesn't feel like anything. And a key consequence of that is that you can build 2 systems, one on the left, which is recurrent, and one on the right, which is the equivalent, purely feed-forward version of that recurrent system, which have exactly the same input-output function here up to a t equal 4. So they do exactly the same job. You could treat them, they behave equivalently for any question and answers you want to get from them. And yet, if you do the analysis according to IIT, The one on the left feels like something, is something, exists. The one on the right, we can use it, but it doesn't exist at all in and of itself. So there is functional equivalence without conscious equivalence.
Integrated information theory can sort of extrapolate to these cases that are much more ambiguous based on the circuit complexity and the cause-effect repertoire. But the ones that I wanted to mention is this remarkable prediction of integrated information theory that says, although you can get systems that are equivalent to within a certain time step in terms of their I/O behavior, which is typically how we assess, of course, in the Turing test. The Turing test is all about input-output behavior. So here you have two systems on the left and on the right, the ones that Giulio showed before, that have the same I/O behavior. Yet they have very different circuitry. So one has this heavy feedback circuitry, the other one is a purely feed-forward system. The theory says quite unambiguously that the system on the right has no phi. It doesn't. The system is reducible to its component. It doesn't exist in this sense, but of course it can act. It can, for example, process information. It can detect faces. A lot of the standard machine vision algorithms, for example, the Google cat detector, are of this ilk on the right. They are a series of cascaded feed-forward systems. These deep learning networks are nothing but a set of standard neural networks that are cascaded one after the other. So the theory would say, although these systems do perform useful computational function, i.e. they find faces and cats, they don't have, it doesn't feel like anything to be them. Which is really quite, so here the theory really differs very much from the standard way of viewing. It's not about the input-output behavior, it's about the internal circuitry, the internal cause-effect repertoire. So there are a number of systems that do not have sentience, that do not have conscious. On the one hand, IT says many systems that have complex integration going on, including possible or multicellular organisms, or possible or biological organisms, or even beyond that, may have phi different from zero. I.e., it feels like something to be these systems. It's not standard panpsychism, right? Standard panpsychism claims that everything is ensouled, everything has consciousness. A dumb system, a system that has no states, for example, is not conscious, like, you know, if you want to think about a grain of sand. An aggregate of systems, if I just take a bunch of individual systems, so for example, here, if we consider the consciousness associated with this meeting, it is not, there isn't any meta-consciousness, it's just the consciousness of aggregate is just the consciousness of the individual components. Unless the degree of interaction is so high that it extends the integration within my brain, and then you can have a meta-consciousness, you can have this higher Uber-consciousness. The theory would then also predict that the individual consciousness would immediately become extinguished. So as I said, feed-forward computational systems are not conscious, and there's a very interesting case of computer simulation. So the field is setting out to model, or has done over the last 20 years, does very large-scale modeling. There's now a human brain project in Europe that has the goal over the next years to try to model a human brain. In the limit, once this becomes possible, let's say in 50 or 100 years, we can ask, will this, assuming that this entity, this perfect human brain model, can simulate the I/O of the brain? Most people would say, well, if it simulates all the causal elements of a brain, then of course it's conscious. But the case is much more difficult, as you saw in this previous case. It really depends on the underlying circuitry. Now, in particular, on digital machines, of course, ultimately they can all be reduced to Turing machines, right? So you have this one-dimensional Turing machine, although it may be a very, very big one for the human brain simulation. So you really have to ask the phi associated with the simulation is not the phi of at this meta level, but actually would be the phi of the Turing machine, and ultimately the phi of the underlying hardware, and that may be zero, it may be very small. So the relationship between consciousness and what's being simulated here is very complex and may be very different than most philosophers or people who think about these imagine. And then lastly, of course, I just wanted to leave you with this, my last slide. This is the most complex artifact people have ever built. It has on the order of 10 to the 18 components, and I'd like to, transistors, right? This is one depiction of the internet. And if you just count the transistors in this internet, it has 10,000 times more transistors than synapses in the average human brain. So it is complex by any measure of complexity. We don't know at this point whether it has any phi, but I think it's an interesting question. At least it's a question that we can now at least have a meaningful way to reason about. It's not a crazy question. To what extent does it feel like anything to be such an entity? Thank you very much.
Given this one equation, it's natural to ask, so what can you do with this? How predictive is it? Does it predict human-level intelligence? Does it predict artificial intelligence? So I'm going to show you now a video that will, I think, demonstrate some of the amazing applications of just this single equation.
Recent research in cosmology has suggested that universes that produce more disorder, or entropy, over their lifetimes should tend to have more favorable conditions for the existence of intelligent beings such as ourselves. But what if that tentative cosmological connection between entropy and intelligence hints at a deeper relationship? What if intelligent behavior doesn't just correlate with the production of long-term entropy, but actually emerges directly from it? To find out, we developed a software engine called Entropica, designed to maximize the production of long-term entropy of any system that it finds itself in. Amazingly, Entropica was able to pass multiple animal intelligence tests, play human games, and even earn money trading stocks, all without being instructed to do so. Here are some examples of Entropica in action. Just like a human standing upright without falling over, here we see Entropica automatically balancing a pole using a cart. This behavior is remarkable in part because we never gave Entropica a goal. It simply decided on its own to balance the pole. This balancing ability will have applications for humanoid robotics and human assistive technologies. Just as some animals can use objects in their environments as tools to reach into narrow spaces, here we see that Entropica, again, on its own initiative, was able to move a large disk representing an animal around so as to cause a small disk, representing a tool, to reach into a confined space holding a third disk and release the third disk from its initially fixed position. This tool use ability will have applications for smart manufacturing and agriculture. In addition, just as some other animals are able to cooperate by pulling opposite ends of a rope at the same time to release food, here we see that Entropica is able to accomplish a model version of that task. This cooperative ability has interesting implications for economic planning and a variety of other fields. Entropica is broadly applicable to a variety of domains. For example, here we see it successfully playing a game of Pong against itself, illustrating its potential for gaming. Here we see Entropica orchestrating new connections on a social network where friends are constantly falling out of touch and successfully keeping the network well connected. This same network orchestration ability also has applications in healthcare, energy, and intelligence. Here we see Entropica directing the paths of a fleet of ships, successfully discovering and utilizing the Panama Canal to globally extend its reach from the Atlantic to the Pacific. By the same token, Entropica is broadly applicable to problems in autonomous defense, logistics, and transportation. Finally, here we see Entropica spontaneously discovering and executing a buy low, sell high strategy on a simulated range-traded stock, successfully growing assets under management exponentially. This risk management ability will have broad applications in finance and insurance. So what you've just seen is that a variety of signature human, intelligent, cognitive behaviors, such as tool use and walking upright and social cooperation, all follow from a single equation, which drives a system to maximize its future freedom of action. Now, there's a profound irony here. Going back to the beginning of the usage of the term robot, the play R-U-R, there was always a concept that if we developed machine intelligence, there would be a cybernetic revolt. The machines would rise up against us. One major consequence of this work is that maybe all of these decades we've had the whole concept of cybernetic revolt in reverse. It's not that machines first become intelligent and then megalomaniacal and try to take over the world. It's quite the opposite, that the urge to take control of all possible futures is a more fundamental principle than that of intelligence, that general intelligence may in fact emerge directly
from this sort of control grabbing rather than vice versa. Another important consequence is goal seeking. I'm often asked, how does the ability to seek goals follow from this sort of framework? And the answer is, the ability to seek goals will follow directly from this in the following sense. Just like you would travel through a tunnel, a bottleneck in your future path space in order to achieve many other diverse objectives later on, or just like you would invest in a financial security, reducing your short-term liquidity in order to increase your wealth over the long term, goal seeking emerges directly from a long-term drive to increase future freedom of action. Finally, Richard Feynman, famous physicist, once wrote that if human civilization were destroyed and you could pass only a single concept on to our descendants to help them rebuild civilization, that concept should be that all matter around us is made out of tiny elements that attract each other when they're far apart, but repel each other when they're close together. My equivalent of that statement, to pass on to descendants to help them build artificial intelligences or to help them understand human intelligence, is the following. Intelligence should be viewed as a physical process that tries to maximize future freedom of action and avoid constraints in its own future. Thank you very much.
Kind of friend of mine, I consider it a friend really. Here's a Eupholus weevil. And these guys are wonderful. And there's a huge diversity in the appearance. Some of them look like, I don't know what the appropriate word to use is, especially online, like bird poo. I've got 4 young children, and poo is a very common word we use all the time in the house. So yeah, so some of these patterns arise because either they're very attractive and they're conspicuous signalers, or they've got black background, some white patches here or there, some sort of yellowy browny patches here or there, to mimic bird droppings so that they're not predated upon or preyed upon. So this is a wonderful species because of the 2 different types of color that we see. The black region stripes actually is interesting for another purpose. People, it's very fashionable and very useful to wear a black suit or a black dress. How do we get good black? How do we get good white? Those are questions that the biological systems can actually provide some help with. But here we've got 2 different colors. The scales from this region, these are about 30 microns in diameter, so they're relatively small. And it's the structure within these 2 different sorts of scales which generates the color, the interaction with light. So in these sorts of scales, from that greeny blue region, we see wonderful 3-dimensionally ordered crystals. Photonic crystals. I don't mean atomic or semiconductor crystals, but photonic crystals. The length scale of this periodicity here is about 200 or 300 nanometers. Great. So that's a kind of that color, and we think, what's the bug doing to get this color? Surely it's just changing the lattice constant a little bit. Turns out that's not the case. When we looked at the scales from this region, we see something entirely, well, it's not entirely different, it's related, but structurally, geometrically, it's very different. Suddenly, instead of a high degree of order, we see a high degree of what you might expect to be disorder. Clearly, it's not disordered because we still get a strong color reflection. If it was disordered, we'd scatter simultaneously all wavelengths. This is sufficiently ordered. Somewhere on the sliding scale between highly ordered photonic systems and highly disordered photonic systems, somewhere along that sliding scale sits this structure and this color generation. Now, a big question was, what's the cost and what's the benefit? Well, clearly, that should give a purer color, and that, as I've intimated, should give a much sort of broader color. We have a facility in Exeter to measure the BRDF, the bidirectional reflection distribution function. If I have a sample here on the table and I shine light straight down onto it, depending on the nature of the sample, I will get light scatter into the hemisphere above this. If I could pick that hemisphere up and flatten it, it would look like a circle, and at the edge of the circle would be the horizon. So there it is. The reflection from that scale, there's the horizon, there's a 60-degree line, there's a 30-degree line, and that's a 5-degree line. The highly periodic structure gives pure color, and it gives a narrow reflection angle. That might be a benefit. It might be a cost if you want broad visibility. But this relatively disordered system, the color purity it produces is much reduced, but then the scattered angle is increased. So it's a trade-off. It's a balance. And by looking at some of these systems, we can start to get a feel for the cost and the benefit of moving from ordered photonic systems, colored systems, towards disordered systems. We wanted to understand what generated such brilliant color in this, and perhaps slightly less brilliant color in its cousin species, Lepidiota. The scales are tremendously white, reminding me of when I used to go, before kids, skiing in France. You know, the roof tiles of these French French houses were just like this, in my early memory. So let's take one of these scales and damage it and have a look underneath and just see what we see. Inside the scale, we see a scattering structure that is truly disordered. And the disorder of these interconnected filamentary networks, that scatters all wavelengths across visible, near UV, near infrared, very efficiently. The polydispersity and the anisotropy of these scattering centers is remarkably efficient. And the efficiency specifically lies in the filling fraction. How packed are these scattering centers? Well, they're not very packed. There's a lot of air. The light gray in here is air, and that is responsible for the bright whiteness, the brilliant whiteness that we see. So that pretty much leads me to the end, and I think I'm bang on 30 minutes. I've got a couple of short summary slides. The first one of which, I've got a lovely video in the background that I'd like to try to start. There it is. So what message should we take home from this? I'd like to draw up a set of rules that we might refer to with respect to smart clothing in biological systems. Any type of color appearance that we can perceive is usually already evolved and has been presented to us in these biological systems. It encompasses order, quasi-order, and disorder along some sort of curious sliding scale of that structure. The fact that these biological materials can just grow is remarkable and is something that we must surely aspire towards. The take-home message from today that I often try to, at the end of a day at home, get home from work and we do bath time and reading time and dinner time and I tuck the kids in. What did you enjoy today? What did you learn today is often what I try to bring home. Well, the key message today, the tuck-in message, if you will, is that these biological systems tolerate imperfection with respect to the mechanisms generating their appearance. And that fault tolerance is a remarkable quality that surely we must try to chase. Finally, lots of
found. What they had in common was a sense of courage. And I want to separate courage and bravery for you for a minute. Courage, the original definition of courage, when it first came into the English language, it's from the Latin word cur, meaning heart. And the original definition was to tell the story of who you are with your whole heart. And so these folks had, very simply, the courage to be imperfect. They had the compassion to be kind to themselves first and then to others, because as it turns out, we can't practice compassion with other people if we can't treat ourselves kindly. And the last was they had connection, and this was the hard part, as a result of authenticity. They were willing to let go of who they thought they should be in order to be who they were, which is, you have to absolutely do that for connection. The other thing that they had in common was this. They fully embraced vulnerability. They believed that what made them vulnerable made them beautiful. They didn't talk about vulnerability being comfortable, nor did they really talk about it being excruciating, as I had heard earlier in the shame interviewing. They just talked about it being necessary. They talked about the willingness to say I love you first. The willingness to do something where there are no guarantees. The willingness to breathe through waiting for the doctor to call after your mammogram. The willing to invest in a relationship that may or may not work out. They thought this was fundamental. I personally thought it was betrayal. I could not believe I had pledged allegiance to research, where our job, the definition of research is to control and predict, to study phenomenon for the explicit reason to control and predict. And now my mission to control and predict had turned up the answer that the way to live is with vulnerability and to stop controlling and predicting.
Love 2.0 describes that energizing micro moment that you feel when you truly connect with someone else. You meet eyes and you share a common source of positivity. Now, whether that emerges between you and your soulmate or you and a complete stranger, it provides powerful nourishment for your growth and your health. This book started as my data drew me to rethink love from the ground up. I've been studying positive emotions for decades, yet my latest data were telling me that the positivity that you feel when you're connecting with others nourishes you more than any other source of positivity.
The warmth of our everyday greetings as one of the wonders of this world. Now those wonders run even deeper because when you really connect with another person, a beautifully choreographed biological dance is unfolding. As your smiles, gestures, and postures come to mirror one another and come into sync. But when you're really connecting with somebody else, your heart rhythms come into sync. Your biochemistries come into sync. Even your neural firings come into sync. It's as if in that micro moment, a single positive emotion is rolling across two brains and bodies at once, creating a momentary resonance of good feeling and goodwill between you. Now, what's more is that as you have more of these micro moments of connection in your daily life, it changes you. It changes you for the better, not just socially and psychologically, but also physically. And I've become particularly interested in your vagus nerve. Your vagus nerve emerges from your brainstem and tethers your brain to your heart. And one of its jobs is to slow your racing heart after a fright. But when your vagus nerve is functioning really well, it also slows your heart rate just a bit each time you exhale. Now, what happens in Vegas doesn't necessarily stay in Vegas. It radiates out to affect your health more generally. It reflects your body's ability to regulate inflammation, to regulate glucose, as well as your heart rate. And it also establishes your biological capacity for connection. Now, scientists used to think that your vagus nerve functioning was rather stable, kind of like your height once you're an adult. But what we've discovered is that if you find ways to increase your daily diet of these micro moments of connection each day, your vagus nerve functioning improves. The very rhythms of your heart become healthier. So these micro moments of connection are positive health behaviors every bit as much as eating your vegetables, eating your kale, or being physically active. But and how much more enjoyable and easy is connecting than doing some of the other health behaviors that we need to do. And this isn't just about your health, because when you're really connecting with someone else, your heart is getting a mini tune-up, and so is theirs. So you are wired to connect. And what we're learning is that the vagus nerve is a key part of that wiring. But I don't want you to be thinking about this wiring as mechanical wiring that stays the same season to season. This is living tissue. Your vagus nerve is living tissue, and it changes season to season depending on your habits of connection. The more you connect, the more you fortify this wiring to connect, and the more you lower your odds of having a heart attack and increase your odds of living a long, happy, and healthy life. Now, this gives me goosebumps. I mean, we've hardly been giving these micro moments of connection their due. When we say we had rapport, or we really connected, or sort of on the same page, we're in a way subtly suggesting that the goodness of our connection is somehow optional. It's icing on the cake. When these discoveries suggest that these connections are biological imperatives, they give you life.
That love is more than flowers and chocolates. That love is, in fact, a life-sustaining, physiological thing that happens in our brain. In the broadest of strokes, explain what that thesis is all about.
Well, as science has learned more about the brain, we know that love is not just a feeling, or it's not just chocolates, as you're saying, that it's actually a connection between two living brains, and a connection of some considerable power over the mind and the body. And we know that across this connection that people establish, they can send information back and forth, they can regulate each other's bodily rhythms across that link, and they can even change the structure of each other's brains across that link. And that totality is what love is.
Now, this part of the brain that is the focus of most of your work, the limbic brain, I mean, deals with emotion and how we relate to one another. Explain how that works for me.
Well, when mammals first evolved, they had something of a difficult problem. Reptiles give birth to eggs, which don't need any care, but mammals give birth to live, helpless animals that need quite sophisticated care if they're going to survive. So that a parent mammal has to be able to discern if the infant is hungry or tired or cold or thirsty or what it needs, and provide for those specific needs, or the infant will die. So mammals evolve parts of their brains that are oriented specifically towards sensing signals that come from another mammal, interpreting them, and feeling disposed to care for the needs that are sensed there.
So this is more than simple emotion. This is more than happiness or sadness. This is a part of us that is hardwired to understand how the other person is feeling. And
we get a direct sensory experience, actually, of the insides of another person's brain, which is quite remarkable if you think about it. But if you and I knew each other well, I could sense what's going on in your brain.
Pretty wide-held conventional wisdoms. I mean, among them, and for me, one of the most shocking was the fact that you were found through your research that mothers who suffered depression were 4 times more likely to have children who experienced sudden infant death syndrome, SIDS, and that in fact the incidence of SIDS is higher than in America than anywhere else. What is the linkage you're trying to develop here?
Well, SIDS has been a mystery for a long time, and of course usually parents put the child to bed and then the child dies with no apparent cause. And one of the really cutting-edge lines of thought that's evolving about sudden infant death is that in light of what we're talking about, say, people establishing these vital regulatory ties, it's especially vital between parents and infants who are fragile, actually, and probably have the most vulnerable bodies and minds and brains imaginable. And that what sudden infant death may represent is a failure of that regulatory process, that the infant is not getting enough regulation from a parent, and its own cardiorespiratory brain rhythms can't be sustained on its own, and they collapse and the infant dies. And there's some fascinating research done by James McKenna, a sleep scientist at Notre Dame, who studied infants and children, infants and mothers sleeping together, and he was the first person actually to study this. And he found that their sleep rhythms are intertwined during the night, that they're each regulating each other's sleep level. And the hypothesis is that if you take infants out of that communal context of sleep, you may be depriving them of a vital physiologic influence they need to stay alive during the night.
Well, and that in fact the higher incidence of SIDS may reflect the cultural bias against parents sleeping with children.
It may, because one of the puzzles of SIDS is that its incidence varies so widely in the world. The United States has the highest rate in the world, 2 per 1,000 live births. Some countries have rates that are 10 or 100 times lower. And so the question is, what is that cultural factor in this country that is putting our children at risk. And one of the ideas that we're raising in the book is it could well be that our culture discourages close contact between infant and parent, particularly at night.
Now, this also has fairly widespread implications. If how a child is loved during childhood, and especially the proximity between the child and the parent, the mother in this particular instance, directly affects both their health and how they love in the future. Are we to conclude, therefore, stay-at-home parenting is better for a child, better for society, than two parents working?
There's no question, actually, that stay-at-home parenting is better for children. Now, the real question is how much better? Is it so much better that parents should do that, or is it so much better that we should make a big effort to revamp our society? And the evidence is mounting that because the parent and child have this regulatory relationship along this brain pathway, the parent is actually regulating the development of a child's growing brain, because the child's brain is growing by tremendous leaps and bounds, especially in the first couple of years of life. And that during this vital period of brain growth, normal development of the brain depends on that special biological connection with the parent's brain. If we interfere with that and don't allow children enough exposure, we could be depriving them of something which helps make their brain turn out the healthiest.
Can daycare be a surrogate for parental love in that respect, do you think?
Probably not, actually. Most daycare, as it's conducted, is of the impersonal variety. The children are cared for by a rotating series of impersonal caretakers, that there's a lot of staff turnover, there's very little personal interaction between the infants or the children and the staff. And these are really conditions that are hostile to the biological needs for connectedness that children have. So institutional kinds of daycare, because of the element of impersonality that they necessarily inject into a child's life, are hostile to those needs. Now, and again, the real question is, how hostile are they? How many hours of impersonal daycare can a child sustain before the mind is at risk?
Right. Now, some of this directly challenges early childhood development theory. I mean, part supports to the extent that there's no question that relations between parents and child, have a major part in forming the brain in that crucial 0 to 3, 0 to 5. But this also suggests, unlike early childhood development theory that says everything's finished, you're fully formed, that this isn't the case at all, that our evolution as human beings, the state of our brain is ever changing and evolving and conditioned based on who we love.
Exactly. And the more we learn about the brain, the more we learn about how changeable it actually is. So there's more and more reason to think that it's changeable. Just in the past year, we used to think that the number of cells in the brain was fixed and you couldn't get any new ones. Now we know that the brain adds thousands of new cells every day. So it's clear that the brain does change on an ongoing basis, and that our relationships are a vital part of what makes it change, and makes it change in certain directions. And that occurs across the lifespan right up until the day we die.
They're going to help us. You can read all you want about having a better love life, and it's not going to work. Is that right?
That's very true. Reading and getting self-help advice all impacts the thinking brain, but it doesn't impact the emotional brain very much at all. And really what impacts the emotional brain is the experience of relatedness, or the experience of being with somebody. So that's actually what changes people. And self-help advice, as well-meaning as it's intended to be, and even if it's very good advice, is not going to change anybody in a lasting way.
Now, I know you're a scientist rather than one of these self-help people, but assume for 1 second that I am interested in a better relationship. I'm convinced of the salutary effects that it will have on my health and my well-being. But as you've also pointed out, relationships aren't easy. They need work. What do I do? Just spend more time with the individual, and then over time my brain will find the right rhythm? Or am I just kind of doomed to muddle along?
Well, it depends, of course, on you in an individualized sense, what you're doing in the relationship, how well you're performing it. Say, like if it were a tennis game, it depends on both your skill level and your partner's skill level. And sometimes you can coax your partner to a greater skill level, and sometimes they can teach you better things. There certainly are times when you would have to conclude, well, this person just is not up to the task of relating.
Well, I was going to ask you, can you love practically anyone?
No, I don't think so. Some people are not good enough at it, first of all, so that they're, just like, can you play tennis with practically anyone? No. Some people hit the ball into the net every time, and it's very unsatisfying to play with them, and eventually you give up. But there's also an element of specificity, because what people notice, which is very interesting, is that out of all the people in the world, out of all the 6 billion people there are, there's actually relatively few that people are interested in pursuing, kind of attracted or drawn to. Even out of those people, there's very few that people, even out of that selective set,
really connect.
It's even narrower that people have a long-term successful connection.
Why is that?
Well, it's partly because in childhood, we learn to speak the emotional language of our parents, in a sense, that they teach us how relationships work and how they ought to function, and we absorb that knowledge, and even though we were without realizing it, we may not know it, we may not even know that we've learned anything, and when we go out into the world, we gravitate towards people who know the same thing that we do, who speak our same emotional language.
Now, among other heresies that are exploded in the book is therapy. I mean, everyone goes, not everyone, many of us go to therapists in order to improve our love life. And you're saying that, again, therapy doesn't work, or if it does, certainly not the way we expect it to work.
Well, therapy certainly can work, and it can be powerful for some people, but not in the way that most therapists, including most patients, think about it. Because if you realize that a relationship is really this biological, physiologic link between two emotional brains, then suddenly therapy appears in a whole new light. It's not just two people talking to one another, having a conversation. It's really this wireless emotional link, and what's being performed in the therapy should be an experience of relatedness that's different than what the person experiences outside. And that's really the changing aspect of theory, or the mutative aspect of therapy, is that new relationship, not, say, any particular insights or any particular intellectual knowledge.
So it's not the content of the therapy per se that may be helping, it's the fact that over time you might become more like the therapist.
Precisely.
Which is stable and reasonable and...
Precisely, if you have a stable, reasonable therapist. And not everybody does. But people probably ought to be aware of that and ought to try and choose their therapist with a lot of care and discrimination, because essentially you're asking to become more like that person.
Early in life, the limbic brain develops emotional attractors. In other words, our early experience with those around us becomes encoded and affects who we then become attracted to. This bias forms an integral part of the neural systems that view the emotional world and conduct relationships.
Relationships have a kind of grammar to them, or a kind of internal structure or coherence. And what happens between two people has a regularity in it that's discoverable. The brain of a child studies, if you will, the relationships that are going on around him or her, and pulls out the regularities and learns those regularities or rules, just as they learn the rules of their native language. Depending on the kind of family you have, that may serve you well or it may not serve you well. And if emotional interactions in the family take place that are eccentric or are not really valid when applied to the larger world, people will not be speaking the same emotional language that everybody else knows. And in our practices, we see a lot of those people, they're often baffled about how relationships work, what goes on in them. They don't understand what they don't know. Often they don't know that there's something they don't know. An attractor is that kind of intuitively acquired, ingrained pattern of implicit memory. Say if you grew up in a family where when you expressed your opinion, somebody yelled at you, you learn something from that. It's not just that experiencing it is unpleasant, which it is, but your brain learns actively about what the structure of the world is like, what you can expect from a given interaction, and it changes how you see the world forever. And one of the actions of attractors is not only to prepare people to act in a certain way, but they also alter incoming sensory information so that people don't see reality. They see sensory data that's been filtered and compressed by their attractors into much simpler things. And if your attractors are not accurate, say, you won't be seeing the real world very clearly.
So this encoding of the limbic system is malleable. It can change and adapt by constant interaction with the compatible limbic system of another.
There's a lot more to share with you. I don't really talk about cows. We are designed as a very social species. We're designed to connect. Did you know that FaceTime, time in the physical presence of our loved ones, actually puts the brakes on our stress response? Did you know that our ancestors spent all day, every day in the company of their loved ones, their friends? Think about the extensive FaceTime they shared with the people that matter most. And what have we done? We've traded FaceTime for screen time. FaceTime for Facebook, is that better? And the result is devastating. The result is devastating. We're born to connect. We need that connection in our treatment protocol. We work very, very hard to help each depressed individual resist the urge to withdraw, because when you're ill, your body tells you to shut down and pull away. When you're physically ill with the flu, that's adaptive. When you have clinical depression, it's the worst thing in the world you can do, even though every fiber of your being is telling you exactly the opposite. We've got lots of good data on our outcomes, and as I've said, they've exceeded our wildest expectations. Most of the patients that have come to us have tried meds, and they haven't gotten well. Most of them have tried traditional therapy, and it hasn't been the answer. The majority have gotten well as they've been willing to change the way they live. We had a man a year and a half ago who had been fighting depression for 41 years consecutively. And it was one of the happiest days of my life when he came into a session after 14 weeks, and he looked around the room with tears in his eyes and said, "This is what I remembered it felt like to be free." It matters to the brain. Have you heard of rumination? It's the habit of dwelling on our negative thoughts repeatedly at length. It ramps up our brain's stress circuitry, and that in turn interferes with the whole process of memory consolidation. It's the big reason why memory tends to suffer whenever we're stressed and we get trapped inside our own heads. And the research shows we're most likely to ruminate whenever we're completely alone. On the other hand, FaceTime with our loved ones, it doesn't just protect us against toxic rumination. It also directly puts the brakes on the brain's stress response. And the benefits can range from lower anxiety to better quality sleep to, yes, better memory. Now, whenever we hear the term chemical imbalance, most of us, I think, reflexively assume medication must be the answer. And yet the relevant neuroscience leads us to a somewhat different conclusion. There are many different ways of changing neurochemistry. Most of them have nothing to do with medication. It's why I believe in the long run, the most effective way of balancing neurochemistry is to balance our lives. Remember, experience changes the brain. Thank you.
Whenever you have an experience, you devote more of your brain to processing that. And so when you get something, be it academic or sports or music or a thought, it's just that connection is now strong. Now, an important point here is all experiences change the brain. So when you're in a college class and you learn some fact, you've changed the brain. But also the whole college's experience is affecting the brain. Students are often under great pressure. They're often overtired, and this also changes the brain. When you're under high stress and fatigue, what happens is something called downshifting. Downshifting. You shift down to a more primitive style of functioning where the back part of your brain here, which is your concrete sensory area, talks to the motor system, and that's it. You're in a more of a stimulus response mode. Someone comes up and says, "Your hair doesn't look very good today," and you get really angry at them. You don't have to get angry at them. They may be making a joke. What's happening is under stress and fatigue, or maybe your hair doesn't look good. Some people don't have to worry about it. Under stress, under fatigue, what happens is this front part of the brain here. This is the CEO of the brain. This is where David Lynch is in your brain. This is the director. All other parts of the brain send their information to the front, it gets integrated, it's sent back out. Under high stress, these connections are not used. And when you actually have connections of this part of the brain and someone comes up and makes a comment about your hair, you say, oh, you didn't get a good sleep last night, or it's a joke, or he thinks I'm somebody else. You're not responding to the surface value of that relationship. You can see more fundamental to it. Now, what does happen over time under high stress and fatigue is this area, the CEO of the brain, is just not involved in usual experience. And that's what this picture is of. These are people lying down. This is their spinal cord, so their feet are coming out at you. You're looking up at the top of their brain. This is where the eyes are, and these are both during eyes closed rest. And what we're looking at is brain metabolic rate. Now, this Swiss cheese you see over here, they're not really holes here, but these are areas, these are functional lesions. That is, these parts of the brain are not involved in whatever you're doing. What this means is that you can, and this is, by the way, a very violent individual. It's a criminal. It's not a college student. But high drinking, high stress, mental stress, physical stress results in this. The brain is constantly being rewired. So you may be wondering what can strengthen these frontal connections, and transcending does this. It actually directly exercises the frontal area. It makes it alive. It connects it with the other parts of the brain.
Your stress response wants you to be surrounded by people who care about you. Okay, so how is knowing this side of stress going to make you healthier? Well, oxytocin doesn't only act on your brain, it also acts on your body. And one of its main roles in your body is to protect your cardiovascular system from the effects of stress. It's a natural anti-inflammatory. It also helps your blood vessels stay relaxed during stress. But my favorite effect on the body is actually on the heart. Your heart has receptors for this hormone. And oxytocin helps heart cells regenerate and heal from any stress-induced damage. This stress hormone strengthens your heart. And the cool thing is that all of these physical benefits of oxytocin are enhanced by social contact and social support. So when you reach out to others under stress, either to seek support or to help someone else, you release more of this hormone, your stress response becomes healthier, and you actually recover faster from stress. I find this amazing that your stress response has a built-in mechanism for stress resilience. And that mechanism is human connection. I want to finish by telling you about one more study. And listen up, because this study could also save a life. This study tracked about 1,000 adults in the United States, and they ranged in age from 34 to 93. And they started the study by asking, how much stress have you experienced in the last year? They also asked, how much time have you spent helping out friends, neighbors, people in your community? And then they used public records for the next 5 years to find out who died. Okay, so the bad news first. For every major stressful life experience, like financial difficulties or family crisis, that increased the risk of dying by 30%. But, and I hope you are expecting a but by now, but that wasn't true for everyone. People who spent time caring for others showed absolutely no stress-related increase in dying, 0. Caring created resilience. And so we see once again that the harmful effects of stress on your health are not inevitable. How you think and how you act can transform your experience of stress. When you choose to view your stress response as helpful, you create the biology of courage. And when you choose to connect with others under stress, you can create resilience. Now, I wouldn't necessarily ask for more stressful experiences in my life, but this science has given me a whole new appreciation for stress. Stress gives us access to our hearts. The compassionate heart that finds joy and meaning in connecting with others. And yes, your pounding physical heart working so hard to give you strength and energy. And when you choose to view stress in this way, you're not just getting better at stress, you're actually making a pretty profound statement. You're saying that you can trust yourself to handle life's challenges. And you're remembering that you don't have to face them alone. Thank you.
Thank you. One of the things that I've been most interested in lately is research on something called mindset. And mindset science says that the way that you think about something can actually transform the effect that it has on you. Some of the most fascinating findings include how you think about aging can actually impact how long you live and how well you age. People who have a more positive attitude toward aging live on average 8 years longer than people who have a more negative attitude towards aging. And they actually thrive more, and they preserve all the things that we think are good about youth and middle age. They actually do better as they get older. And some of this new research on mindset says that the way that you think about stress can actually help shape whether its effects are the toxic effects that we fear, like that stress can make us sick, or that stress can lead to burnout, or whether we experience actually much more positive effects from stress. Things like learning and growth and greater engagement with life and with our relationships. If you're anxious and your heart is pounding and you're sweating, if you're able to remember that, okay, well, this anxiety is distracting or distressing, but I also know that that anxiety, that heart pounding, is my body trying to give me energy, that in some way my body and brain are trying to rise to the challenge. Literally just remembering that 5 seconds when you're experiencing anxiety can transform that anxiety into a physiological state that actually gives you more energy, that actually gives you more confidence. So one of the hormones that the body releases during stress is DHEA, which is a precursor to testosterone. It's literally strengthening. It helps the immune system. And its effect on the brain is to actually help make the brain more resilient to future stress. It increases neuroplasticity. And this is part of the normal stress response. And when you choose to view stress as an opportunity to learn and grow, your body and brain actually responds, releases more of DHEA, and actually puts you in a biological state that makes it more likely that you will learn and grow from that stressful experience.
Psychologists told us a lot about misery and suffering and drug addiction and schizophrenia, but there's a way in which that's just half-baked. I mean, a full-baked, what we want to know is what makes life worth living. How about positive emotion? How about meaning? How about spirituality? How about gratitude? How about accomplishment? So the intellectual idea was for psychology to have make full sense of the human condition. In many circumstances, the data are that optimistic people get depressed at only half the rate when setbacks occur, that optimistic people do better than expected on the sports field, in grades, and in many kinds of work, that optimistic people have yeastier immune systems, they're less likely to die of cardiovascular disease, and that descriptively optimistic people are generally liked better. It turns out if you take pessimistic people, depressive people, of which I'm an example, and you teach them principles of recognizing the catastrophic thoughts they're saying to themselves, this interview is going terribly, I've really lost my touch, and then arguing against it. No, you know, Joe's been laughing and smiling at my jokes throughout. Then it turns out you can make people permanently, lastingly more optimistic. The last evolutionary epoch was the Ice Ages, and the mentality that said, you know, it's a lovely day in Philadelphia today, it'll probably be a lovely day tomorrow, got crushed by the ice. And the mentality that was catastrophizing, looks like a lovely day in Philadelphia today, but this is just superficial, and what's really coming in catastrophe is what our intellectual evolutionary forebears, the ones that survived, gave us. So we're bad weather animals, ready to see the most catastrophic. Now,
here are 5 of my favorites. I have a list of about 20. The first is that contrary to the artistic myth, creative people are creative when they're happy and they're not creative when they're depressed. That's number one. The second has to do with attention, that when people are happier, their peripheral attention is better. When people are sad, their focal attention is better. Third surprising finding, optimistic and cheerful people probably live between 8 and 9.5 years longer than pessimistic people. That's about the equivalent of smoking 3 packs of cigarettes a day. A fourth finding is that wealth doesn't do everything that you think it might, that the relationship between wealth and life satisfaction is powerfully curvilinear. That means once you're beyond the safety net, if you're thinking about giving up 5 weekends next year to make an extra $20,000, and what you care about is how happy you're going to be next year, you probably shouldn't do it. You will get more happiness out of spending 5 weekends with your family and friends than you will out of an extra $10,000. And a final finding worth mentioning, if you're interested in who's going to win a presidential election in the United States, bet on the optimist.
So check this out. Carol Dweck and her colleagues wanted to look into the impacts that praise had on children's development. So what they did is they took over 400 5th grade students from all across the nation, and they did a really simple yet interesting study. Here's how it went down. They gave all the kids a really easy non-verbal IQ test. There were 10 questions, and at the end of the test they praised all the children in one of 2 ways. The first group was praised for their intelligence. So they said, "Wow, great job, you must be really smart at this." Now the second group was praised for their effort. So they said, "Wow, great job, you must have worked really hard at this." Now this is a really subtle difference, but the impact it had is incredible. So after praising the kids and getting them divided up into the 2 groups, they gave them all an option for their next test. The first option was, hey, this next test is going to be a little bit harder, but it's going to be a great opportunity to learn and grow. Now the second option was, this next test will be similar to the first and you will surely do well on it. Now the interesting thing is, out of the group that was praised for their intelligence, 67% of them chose the easier option, while 92% of the kids who were praised for their effort chose the harder test. This is unbelievable to think about, how just the subtle difference in the way that they were praised had such an impact. Carol Dweck explains why this happens.
The child or adult hears, "Oh, you think I'm brilliant and talented. That's why you admire me. That's why you value me. I better not do anything that will disprove this evaluation." As a result, they enter a fixed mindset, they play it safe in the future, and they limit the growth of their talents. Whereas focusing on the strategies they use, the way they're stretching themselves and taking on hard tasks, the intense practice they're doing, those are the kinds of things that say to a child or an older athlete, it's about the process of growth. As a result, they don't feel, oh, if I make a mistake, you won't think I'm talented. They think, oh, if I don't take on hard things and stick to them, I'm not going to grow.
Next, Dweck and her colleagues gave all the kids a really difficult test. It was one that they would surely fail, but they wanted to look at how the different kids attacked this challenge. Dweck noticed that the group that was praised for effort worked harder, longer, and actually enjoyed this test more than the group that was praised for their intelligence. This group got really frustrated with this test and had the tendency to give up early. After this artificially induced failure round, all of the kids were given a third and final test. Now this test was the same level of difficulty as the first one, but check out the results. The group that was praised for their intelligence actually did worse on this test than the first one. Their average score actually dropped by 20%, while the group that was praised for their effort did significantly better, raising their average score by nearly 30%. This is a 50% difference in performance that was caused by a few subtle differences in the way that they were praised. This study shows how praise can either make or break a child's development. I mean, we all do it. We all want to be positive with the children we work with, so teachers, coaches, parents are always looking for ways to support their kids and tend to praise them quite a bit. So we need to look at research like this and realize, okay, praise is a good thing and there's nothing wrong with being positive, but we need to be very careful about praising someone's intelligence or abilities and focus more on the process and the effort that they put forth. I think this is a pretty easy fix that will help us develop growth mindsets within the kids that we work with. And as all the research shows, having a growth mindset has a big time impact on the development of a child, whether it's on the court, in the classroom, or just in life.
But the most exciting thing was the students were now believing and expressing the idea that their potential as Native students is unlimited. I want to end with some striking new findings by Leslie, Simpian, and Meyer. They asked whether mindsets could shed light on gender and minority representation in academic disciplines. So here's the proportion of women getting PhD across what we call STEM disciplines: science, technology, engineering, and maths. And you can see how it declines as you get from biology to math, engineering, computer science, and physics. What they did was a national survey of scholars in those disciplines to find out from professors and graduate students what brings success in your discipline. Did they believe being a top scholar, let's say in math, requires a special aptitude that just can't be taught? Or did they believe when it comes to math, the most important factors for success are motivation and sustained effort? Raw ability is secondary. The more a discipline believed in a fixed mindset, that it was sheer brain power that could not be taught, the fewer women and minorities were in that discipline. Conversely, the more they held a growth mindset, the more there were women and minorities in the discipline. Apparently, women do not see this culture of genius as hospitable or amenable to them. So in summary, growth mindset and growth mindset environments allow students to embrace learning and growth instead of worrying all the time, will they look clever or not? It allows them to understand that effort creates talent, rather than believing if you have talent, you shouldn't need effort. And it allows them to stay resilient in the face of setbacks instead of running from errors. And best of all, it can be taught.
In terms of teaching, one of the hardest questions when you think about the evolution of the human species from the standard framework of evolution, which really is about individual survival, competing, getting your genes to the next generation. One of the hardest questions within that framework is, why are people so frequently and routinely good and generous and sacrificing, right? And you know, most people think that Darwin had this idea of survival of the fittest, that really it's the most ruthless and bloodthirsty who really thrive and survive. That is not Darwin's view of human evolution at all. He really felt that sympathy is the strongest instinct that humans have. Communities that have the most sympathetic members will flourish and raise the greatest number of offspring. that notion of Darwin's led to this sense that out of the vulnerability of our offspring emerged, first of all, social structures like cooperative caregiving, and then also physiological systems shaped by evolution to help us take care of the carriers of our genes, our offspring. We have learned from neuroscience down at UCLA that if you feel physical pain, a part of your brain lights up, and if I see you have that physical pain, the same part of my brain lights up. It's as if we're wired to have the same experience of other people. Empathy is this really complicated task. It really engages the frontal lobes, these newer regions of the cortex that are involved in more complex symbolic processes like language and imagining the future. Because empathy requires that you think there's someone else out there who has feelings and thoughts that may be different from mine. That's a really complicated cognitive achievement. In my lab, the Berkeley Social Interaction Lab, we showed images of prototypical suffering to our participants. They trigger massively powerful reactions of compassion, and what we found in the brain is that a very old part of the brain called the periaqueductal gray, which is common to mammals when they take care of things, lights up when you feel compassion. So that tells us compassion is really old in the nervous system, as Darwin speculated. My students and I got really interested in social class. What does it do to the human mind? Our lab and other labs are interested in something called the vagus nerve. It's the longest bundle of nerves in the human nervous system. In our research, compassion, the feeling of caring for someone in need, activates the vagus nerve. Lower class individuals, if we show them images of suffering, they have a vagus nerve response. You don't see that in upper class individuals. It literally is a compassion deficit that's produced by lots of wealth. Next set of studies on charity. Who gives? Economic analyses would say, if I have a lot of money, it should be easy to give. If I have $900 in my bank account, giving away money it really matters. You know, it matters what you put in your fridge. And in spite of that, what we find is lower class individuals give more, and this is replicated in studies of philanthropy. You know, one of the things that this science tells us is there is enormous strength in these poorer communities of generosity and empathy that, you know, many people in more privileged circumstances miss. It's strong community. Yeah, you know, 60% of what we do is really about maximizing an individual's personal gratification and desire, just a classic survival of the most competitive. But 40% of the time, we're really doing things for other people. And we sacrifice and we risk exploitation and we still do it. And not only that, but it actually becomes personally fulfilling and inspiring to engage in that work. We find these secondary delights in acting on behalf of others. And I think that it really requires that we have to redefine human self-interest. You know, the great ethical traditions have always been encouraging this. And now we're seeing the science say, yeah, the brain really cares about other people. So there are regions of the frontal lobes that are now being called the empathy network. And those regions of the brain do a lot of things. But one of the things that they do is they kind of help us detect other people's pain. When you damage the empathy networks of your brain, which some people do, they become really impulsive. And you can have people who are really good citizens of the world, right? And if they have this head trauma and little chunks of the frontal lobes are gone, they'll start swearing suddenly, they start yelling at their kids, they feel disconnected. In the neuroscience literature, they call this acquired sociopathy. Through brain trauma, you become a sociopath. And our lab studies find if you give people a little bit of power, they kind of look like those brain trauma patients, right? So we find, like, if I feel powerful, I flirt inappropriately, I am more likely at work to swear and to act in a rude fashion, I'm more likely to gamble, it makes you impulsive. When you feel powerful, you kind of lose touch with other people. You stop attending carefully to what other people think. In our lab, it's come to be known as the Cookie Monster study. We brought 3 people to the lab. We pointed at one person, we said, you're in charge, right? And so that person kind of felt powerful. And then they had to do this really boring task of, like, write policies for the university. and they're getting kind of bored. We bring a plate of chocolate chip cookies. Everybody takes one cookie. All groups always leave one cookie on the plate because you don't want to be that person that takes the last cookie. So there's that fourth cookie. And we find high power people, they reach out and take it. And then my grad student, Dan Ward at the time, he came to me and he's like, I think people are eating differently when they have power. And lo and behold, our high power person was more likely to eat with their mouth open, lips smacking, crumbs literally like falling onto their sweaters, you know. It's ridiculous. Let's begin with the first, broad generalization in the literature, which is that there are studies showing that positive emotions boost your immune profile. They improve the function of your cardiovascular system, so they calm it down. Positive emotions have been shown to counteract kind of the cortisol response and the stress response in the nervous system. There are data showing that having a healthy profile of positive emotions boosts your life expectancy, anywhere from 5 to 7 years in some kind of broad reviews of the literature. And those health benefits of positive emotions, people know them intuitively. They almost feel them in their chest, right? Like, wow, I volunteered giving food to people who were hungry, and I just felt strong, right? I mean, that's really interesting. Or, God, I was with my best friends, and we were laughing hysterically, and I felt robust. Or I was walking out in the woods, and the leaves were so beautiful, and I came home, and I felt like I could do more sit-ups. Or, I mean, it's this really interesting dynamic between positive emotion and health. And so that begs the question of what do positive emotions do to the nervous system, right? And so what we're learning is positive emotions like compassion and kindness activate the vagus nerve. And the vagus nerve is the largest bundle of nerves starting in the mammalian nervous system. It starts in the top of the spinal cord, activates muscles in your throat, activates cardiovascular patterns, regulates digestion and immune system. And so we have 10 or 12 studies showing when I feel kind and am helping someone, my vagus nerve is activated, and the vagus nerve is great for your physical health, right? So that's one way in which positive emotions benefit health. We once thought, when I started doing research on positive emotion 25 years ago, when no one was studying them, right, or 20 years ago, people were like, the positive emotions are byproducts, they don't matter evolutionarily, and it turns out they're fundamental. The more positive emotion and the more good you bring out in others at the top of a ratio, divided by the less harm you do to others, the bigger the score, the higher the gen ratio, the happier you'll be. And so when I started thinking about that, it's like, well, there are really simple things now we know, like practice gratitude once a week. I just got to take a moment, like, wow, I'm grateful that my dad taught me how to not be so serious in life, express appreciation to other people in a really heartfelt way, pat someone on the back and say, that was an amazing job, right? Touch people in the right way, right? We know there's a lot of data showing the power of healing touch down to oxytocin in the nervous system. For me, what's underappreciated is getting out in nature. We have data showing that 1 minute being around beautiful trees changes your view of life, makes you feel kinder, right? Play. Just make sure, especially with kids, teenagers, rough and tumble, make sure there's always foolish stuff going on, give. So there are a lot of really practical things you can do. I've kind of hinted at them. Play and give and be mindful and express gratitude, find beauty and awe that really, really matter enormously. The meaningful life is about being kind to others and really focusing on others. I think once you take delight in the welfare of other people and really are devoted to them. A lot of other things flow out of that, right, that become part of the meaningful life. So then you feel compassionate. Then you suddenly tear up and get goosebumps when other people do noble things because you have this sort of reverence for humanity. Jen, right? Suddenly other people's acts of generosity become very poignant, right? Like, my God, that person is so good-natured to do this for me. You see a lot of beauty out in the world. So I think it really stems from this kindness and appreciation of other human beings.
But what bums me out is to know that a lot of kids today are just wishing to be happy, to be healthy, to be safe, not bullied, and be loved for who they are. So it seems to me when adults say, "What do you want to be when you grow up?" they just assume that you'll automatically be happy and healthy. But maybe that's not the case. Go to school, go to college, get a job, get married, boom. Then you'll be happy, right? We don't seem to make learning how to be happy and healthy a priority in our schools. It's separate from schools. And for some kids, it doesn't exist at all. But what if we didn't make it separate? What if we based education on the study and practice of being happy and healthy? Because that's what it is, a practice, and a simple practice at that. Education is important, but why is being happy and healthy not considered education? I just don't get it. So I've been studying the science of being happy and healthy. It really comes down to practicing these 8 things: exercise, diet, nutrition, time in nature, contribution, service to others, relationships, recreation, relaxation and stress management, and religious or spiritual involvement. Yes, got that one. So these 8 things come from Dr. Roger Walsh. He calls them therapeutic lifestyle changes, or TLCs for short. He's a scientist that studies how to be happy and healthy. In researching this talk, I got a chance to ask him a few questions like, do you think that our schools today are making these 8 TLCs a priority? His response was no surprise. It was essentially no. But he did say that many people do try to get this kind of education outside of the traditional arena, through reading and practices such as meditation or yoga. But what I thought was his best response was that much of education is oriented, for better or worse, towards making a living rather than making a life.
Once last year I got armor and a sword. I found a dog and played with him. I built a house and made a garden. Night came and monsters were everywhere. There was an evil lord that I started killing. Just as I was about to destroy him, time to line up. Hello, my name is Simon Link, and I'm talking about why kids should have an hour-long recess. Did you know that genes change when they get playtime? Out of 1,200 genes that scientists have studied, 1/3 of them have changed when they had a half-hour playtime. Since the 1800s, research shows that you learn better and faster when having playtime. Work that has breaks is more effective than work with long stretches. Some colleagues visited a school that had no recess. They asked them to have recess twice a week so that they could watch them and see what they were like. They were more focused and less fidgety on days when they had recess. Stress impacts on learning and health. For many children, especially those considered hyperactive, recess is an opportunity to expend energy in a healthy, suitable manner. Recess develops social skills. Recess may be the only time of the day when children have an opportunity to experience socialization and real communication. The outside light triggers the synthesis of vitamin D, which many studies have shown increases academic learning. The outdoors is the best place for children to burn calories, practice emerging physical skills, and experience the pure joy of movement. According to Ray Pica, who is a children's physical activity specialist, recess may be research even shows that you learn. Research even shows that when having physical activity at school. You usually have more physical activity at home, and children who don't have the opportunity to be physically active during the school day don't usually compensate during the after-school hours. Running around helps the brain. Thanks to advances in brain research, we know that most of the brain is activated during physical activity, much more so than being a couch potato. Now, stand up and do 10 jumping jacks when I say go. Go! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now sit down. I imagine a world where every child gets lots of playtime. I hope that if you have children, you will make sure that those children get lots of playtime. Thank you.
One way to change our genes is to make new ones, as Craig Venter has so elegantly shown. Another is to change our lifestyles. And what we're learning is how powerful and dynamic these changes can be, that you don't have to wait very long to see the benefits. When you eat healthier, manage stress, exercise, and love more, your brain actually gets more blood flow and more oxygen. But more than that, your brain gets measurably bigger. Things that were thought impossible just a few years ago can actually be measured now. This was figured out by Robin Williams a few years before the rest of us. Now, there's some things that you can do to make your brain grow new brain cells. Some of my favorite things like chocolate and tea, blueberries, alcohol in moderation, stress management, and cannabinoids found in marijuana. I'm just the messenger. What were we just talking about? And other things that can make it worse. It can cause you to lose brain cells, the usual suspects like saturated fat and sugar, nicotine, opiates, cocaine, too much alcohol, and chronic stress. Your skin gets more blood flow when you change your lifestyle, so you age less quickly. Your skin doesn't wrinkle as much. Your heart gets more blood flow. We've shown that you can actually reverse heart disease, that these clogged arteries that you see in the upper left, after only a year, become measurably less clogged. And the cardiac PET scan shown in the lower left, the blue means no blood flow. A year later, orange and white is maximal blood flow. We've shown you may be able to stop or reverse the progression of early prostate cancer, by extension, breast cancer, simply by making these changes. We found that tumor growth in vitro was inhibited 70% in the group that made these changes, whereas only 9% in the comparison group. These differences were highly significant. Even your sexual organs get more blood flow, so you increase sexual potency. One of the most effective anti-smoking ads was done by the Department of Health Services, showing that nicotine, which constricts your arteries, can cause a heart attack or a stroke, but it also causes impotence. Half of guys who smoke are impotent. How sexy is that? Now, we're about to publish 2 new studies, one in collaboration with Dr. Elizabeth Blackburn, who won a Lasker Prize a couple of years ago for discovering telomerase. Telomerase is an enzyme that repairs telomeres, which are the ends of your chromosomes that control how long you live, obviously pretty important. And what we showed is that simply in just 3 months, by making these simple changes, you can actually increase your telomerase, thereby lengthening your telomeres and living longer. And we're also about to publish a study, the first study showing you can change gene expression in men with prostate cancer. This is what's called a heat map, and the different colors, and along the side on the right are different genes. And we found that over 500 genes were favorably changed. And in fact, turning on the good genes, the disease-preventing genes, turning off the disease-promoting genes. And so these findings, I think, are really very powerful. They're giving many people new hope and new choices. And companies like Navigenics and DNA Direct and 23andMe that are giving you your genetic profiles are getting some people a sense of, gosh, well, what can I do about it? Well, our genes are not our fate, and if we make these changes, they're a predisposition. But if we make bigger changes than we might have made otherwise, we can actually change how our genes are expressed. Thank you. A few days ago. And so when you can meet an unmet need that's as primal as the need for connection and caring and love and community and meaning and trust, that will make you much more successful. But it brings meaning because you're not just making money, you're creating a healing experience for the people that you interact with. And if you look at all of the spiritual traditions, They all have, lots of different things that people fight over. But when you get to the essence of it, what Aldous Huxley called the perennial philosophy, it's all about altruism and forgiveness and compassion and love. What do those things all have in common? They bring us together. I remember the very first study that I did 35 years ago as a medical student. I had 10 men and women in a hotel for a month. And one of them was a guy who hated gay people, and of course one of the other men was gay. And so when they first met, the guy said something insulting to the other. He said something equally insulting back. One got chest pain, took a nitroglycerin. The other got chest pain, took a Demerol. They both slammed the door. I thought they're both going to die, and this is going to be the end of my very short research career. But I talked to them. I said, you're giving the power to give you chest pain and maybe even a heart attack and die to the guy that you hate the most. That's not really smart, even from your own self-interest. And so we need to get away from this idea. Is it selfish or is it unselfish to be forgiving, to be compassionate, to be altruistic? Look what Mark is doing with the Benioff Children's Hospital. That's something that gives him great meaning, as it gives great meaning to all of us who support that. Because so I talked to them and I said, I want you to be more compassionate with each other. Not that it condones or excuses what this guy is doing, but it frees you from the suffering and the pain of having that hatred. Because hatred, as it turns out, is the most toxic emotion, not just to the other people, but to you.
Well, the first thing that I would suggest if you're trying to start a self-healing journey of your own is believe that anything is possible. You have to be able to believe that it's possible to cure yourself from what you're looking to cure yourself from. The second thing I would say is ask yourself this question: what does my body need in order to heal? And be willing to look at the honest truth, because sometimes the answers that come up for people are not, I need to take that drug or I need to get that surgery. Sometimes those may very well be part of it, but it may be, I need to quit my job. I need to leave my husband. I need to move to Santa Fe and go to art school. So it requires a lot of courage to be able to face what that looks like. And then the third thing is take action, write your own prescription, figure out what it is that you need to do in order to make those changes in your life to alleviate loneliness or reduce work stress or become more optimistic or deal with your depression and anxiety or change your life circumstances so that you are in a place to really optimize your body's self-healing response. How can you add more relaxation responses to your life, and then just do it.
Hi everyone, I'm Dr. Lissa Rankin, and I'm so delighted to be able to be here talking to the future of medicine. I was trained as a medical doctor with a very conventional background. I scrubbed in on my first surgery when I was 12. That my father set it up. I was always going to the hospital, so I was very, very much indoctrinated into this very conventional system. And I became very, very disillusioned with my medical practice and my role in it. Even the word healing was something that people were sort of resistant about. This was a time where I was very out of touch with intuition or any sensing capacity of the human potential. Faith was completely separate from intellect and logic and reason, and science and spirituality did not intermingle in my worldview, the way I grew up and the way I was educated. I saw myself like I was outside of myself watching, and I heard myself say to this guy, if I did my job the way you did your job, there'd be dead people everywhere. And then I was like, oh my God, I have become one of these people. But I did end up quitting my job as an OBGYN in 2007, so everybody really thought I was insane. And I still had this deep calling of being a healer, and I just didn't know what that meant anymore. I knew that it wasn't what I had been doing, but I didn't know what it was. And I started doing research, and I came across the Spontaneous Remission Project at the Institute of Noetic Sciences. And this is a database of over 3,500 case studies in the medical literature of patients who had spontaneous remissions from seemingly incurable illnesses. And these case studies in the medical literature, most of them were written up by physicians as sort of medical curiosities or medical miracles. And I got really curious, like, what was happening? Was there something that we could learn from these patients? And this led me down a rabbit hole. And I started researching spontaneous remissions. Anywhere between 18 and 80% of patients get better in clinical trials when they're given a sugar pill or a saline injection, or most effectively a placebo surgery, a fake surgery. So we discovered that there's something about belief. This is not from woo-woo journals. This is from very mainstream medical journals like the New England Journal of Medicine or or the Journal of the American Medical Association. Well-researched data demonstrating that some combination of positive belief and the nurturing care of a healthcare provider, somebody in a white coat that we've given a lot of authority to, who is caring and loving, that when we combine that positive belief with that nurturing care, which is how I define the placebo effect, that something happens to the physical body that can look like a miracle, and maybe it is.
From our perspective, from a shamanic perspective, is kind of a spiritual illness perspective, and I'm saying that that is manifested in limbic dysfunction. What do the shamans say is wrong? They say this person has accumulated too many dark energies, dark spirits, and that's what they're coming for is cleaning. So if we don't treat and clean these energies, the person gets sick. So what do? This is our maloka, we clean. So there is similar ideas throughout all the traditional cultures. Actually, here I am with the Zulus Hangoma in South Africa recently. They do ritual bathing, plant baths, vapor treatments. They're all about ritual cleansing and cleaning, that is a key to health. Do we have anything that parallels that in Western science? It turns out, yes, we do. In the psychoneuroimmunologic world, we have this concept of allostatic burden and load. So it's basically that our stress response system, which is very well defined and described at this stage by psychoneuroimmunology, is burdened over time by accumulated stress, modified and sometimes overburdened and sometimes maladaptive. I'm going fast because I got to go fast. So they have conditions. This is the kind of things, just multiple stresses. How do you measure allostatic load? They have a measurement. It's cortisol levels, adrenaline levels, inflammatory markers. These are all links of the immune system being overburdened by accumulated stress that's sitting and weighing on the system. PTSD, great example, okay, of an overburdened stress response system. Pretty clear. This is Russ. He came to down to the center a while back, treated, got better. From the shamanic perspective, cleaning all the energies and the spirits of the war, that's what we did. So migraine, is looked at as a maladaptive response to stress, injury to the stress coping mechanism. Again, chronic fatigue syndrome and highest allostatic load. Here we see it taking shape and all these illnesses that kind of look kind of spiritual. This childhood, kids that will have their parents die. Here's all the measurements. Their HPA axis, the hypothalamic pituitary adrenal axis stress response system is marked, okay? Psychoneuroimmunology is the study of all this. Here's the brain. It's all very well described. This is the autonomic nervous system, very well described, connected to the whole thing, connected to digestion, connected to erectile dysfunction and all these other emotionally related problems that are so everywhere, connected to our emotions very directly, an expression of our subconscious body controlling our tears, our laughter, our digestion, our upset stomach, our nausea, our vomiting, our diarrhea. Sounds like an ayahuasca ceremony. Here's the limbic system again. There's the hypothalamus sitting in the middle, heading up the stress response system in the HPA axis. And if you go to these other talks, that's psilocybin, there's a hypothalamus. There's other people, there it is. So accumulated energy, stress from childhood, maltreatment, psychological trauma leads to increased allostatic load. Allostatic load represents maladaptive functioning in our psychoneuroimmunologic apparatus, leaves us with less capacity to cope with stress, et cetera, et cetera. So then it's like a stress response system for us. Ayahuasca in a proper ritual setting and ecodos can be effective in cleaning accumulated stress damage, allostatic load burden, often resulting from emotional trauma. Epigenetics, I just want to touch on this. Epigenetics, the coding of the genes, okay? This is the coding of the genes, not the genes themselves. Very susceptible to lifestyle, nutrition, environmental toxicity, psychosocial stress. So now we see, and this is what gets imprinted. Here's them. Oh, it looks like, where is the imprinting happening during maternal imprinting, childhood trauma? Oh, it looks like it's the epigenetics, Attachment theory, these neglected monkeys, what's wrong with them? It's their epigenetics. Early life adversity associated with broad scope of lifelong and health and behavioral disorders. The study examines whether randomized blah, blah, blah. It's basically epigenetics, okay? That's what I want to tell you. It's a growing thing, epigenetic mechanism of depression and antidepressant action. So I think we should explore the possibility that we at the Ayahuasca Healing Centers are cleaning allostatic load, pathologically imprinted epigenetics from our emotional centers, which, by the way, are hardwired into our tears and our vomit, rapid limbic revision. That's what I want to say. And last thing I just want to say is spiritual health, where the rubber hits the road in embodied consciousness, is the emotional health is there. And so we see that. And so Jack Mabit is going to get much more into the spiritual technologies, as other people have talked about, of what we do in shamanism and in technology, but in a way that the larger community is going to understand. emotional health is a place where that's marked. And our limbic system is there, and the epigenetic imprinting of the limbic system is there. So I think this should be a focus of some research. It seems interesting to me.
Of a gene called the reading gene. So this is the ticker tape of a reading gene, let's say. I say, well, what does epigenetics do? Well, I say epigenetics can alter that reading gene by cutting and pasting. So I can cut off part and make the read gene. I can cut off part, make the ding gene. I could cut off parts and make the add gene. And every time I'm doing that, I'm using the same blueprint, but I'm creating a new protein out of it. So what's the point? The issue is simply this. For every gene in your body, using epigenetics, I can create greater than 3,000 different versions of the same protein. Some of those versions are healthy versions, and some of those versions are the equivalent of mutant versions. So, as a matter of fact, you don't have to have a mutant gene. You could have a mutant readout. Epigenetics could take a normal gene and turn it into a gene that reads as a cancer gene. And that's why we're beginning to find out a very important point. Cancer is only about 10% connected to heredity, 90% connected to the environment and your response. And the relevance, as you're quite aware, is simply this. If the signals from the environment are controlling the genetics, then I'm not a victim of my genes. If you wanted to say you were a victim of your environment, you could say that, but that's not true because of a simple reason. You can change the environment. You can change your response to life. You can change all of these. All of a sudden, the concept that you are a victim of your DNA is completely false. You are the master of your DNA. It's your perceptions that send signals to the genes. It's your emotions that send signals to the genes. It's the environment that you live in sends signals to the genes. And all of a sudden you realize, yeah, but I can change my emotions, I can change my perceptions, I can change my environment, and all of a sudden you realize, yeah, you are not restricted to a specific gene readout. You are free to change anything in your life. And this becomes very critical because you have to have self-empowerment. And Evan up here was a great example of self-empowerment. Okay, your body's now screwed up. What are you going to do about it? Self-empowerment. I'm not going to stop. I'm going to control my biology with my wishes, desires, and beliefs. And he did. And that's a great example of changing your life. So I go back and I say, what about that central dogma? DNA goes to RNA, goes to proteins. In all the textbooks, I go, yes, but they left out some pieces that are critical. What'd they leave out? Well, what about the chromosomal proteins, the regulatory proteins? Yeah, they control the reading of the DNA. Oh, you left them out of the story. And I go, yeah, but what controls the regulatory proteins? And the answer is the environmental signals. And all of a sudden, you don't live by the primacy of DNA. You actually are representing the primacy of the environment. And all of a sudden, it becomes very important for you to understand that you change the environmental signals, you change the expression of the protein at the bottom. Okay? So basically, I go back to my tissue culture study and I say, yeah, I put cells in a petri dish, change the environment, and I can change the fate of the cells, changing the culture medium. You say, yeah, but that's cells in a plastic dish, Lipton. What about cells in me? I go, well, here's the interesting fact about you. You see yourself as a single living entity, but the truth is, no, you are actually you're a skin-covered petri dish. You got 50 trillion cells inside your body. How does it work? And the answer is simply this. The cells respond to the culture medium. I go, what's the culture medium in your body? The answer is the blood. So I say, so if you change the chemical composition of the blood, it's the same as changing the culture medium in a plastic dish? I go, absolutely. To a cell, it doesn't make a difference if it's in a skin dish or a plastic dish. It's still going to respond to the environmental signal. I say, so the blood in your body is the culture medium. I go, yeah. And I say, what controls the chemistry of that culture medium? Because if you change the chemistry, you change the fate of the cells. I go, well, you read environmental signals with what? Their nervous system. It's perception. I perceive what's going on in the environment. But that's not the end of it, because the next level of control is more important. It's not just the nervous system response to stimulus response. It involves the mind. And why is the mind relevant? Mind is interpretation. And the significance of this, two people can be in the exact same environment, having the exact same influence of environmental signals, but with two different perceptions of what's going on, they have two different totally responses in their body. So all of a sudden, it's not the environment, it's your perception and your interpretation of the environment, which is the mind's role. And when the mind interprets, what it does is send signals back into the brain, and the brain releases chemicals that are matching the interpretation. And those chemicals are sent into the blood, or those chemicals are sent via the nervous system to the cells, and the relevance is at the cells, the signals, just like in a plastic dish, the signals control behavior and gene activity. And all of a sudden you see what's at the top of this whole thing is the mind. I go, well, what chemicals should the mind release? Well, I say, well, I was a cell biologist, but we are all, every one of us, self-biologists. And we are creating our biology. As it shows, the brain is creating the culture medium, the blood, and culture medium is being used to feed the 50 trillion cells in your body. I say, well, what's relevant? I say this, you open your eyes, you see someone you love. Oh, when you see someone you love, what kind of chemicals go into blood? Dopamine, oxytocin, vasopressin, growth hormone. I say, why are those chemicals relevant? I can tell you a simple fact. If I take those chemicals, add them to my plastic petri dish of cells, the cells grow exuberantly well. I say, isn't that interesting? When people fall in love, they're so healthy they glow. Why is that? And the answer is the chemistry in their body is fulfilling the fullest growth potential of your cells in love. I say, well, what about the same person? They open their eyes, but they don't see someone they love. They see something that scares them. I say, oh, fear, that releases a completely different set of chemicals. When you're experiencing or perceiving, interpreting fear, you release stress hormones and inflammatory agents. I say, why relevant? I say, take the stress hormones, inflammatory agents, add them to the petri dish and plastic petri dish with cells, and guess what? The cells stop growing. And that's why fear kills. It's an effort of the system to conserve energy. So don't grow if you have to run away from the tiger. Stop growing and use that energy for escape. Well, it was only meant in history to run away from the saber-toothed tiger. Meaning, okay, you got 20 minutes, scare the hell out of you, and you get away from that tiger, and then guess what? You relax and you go back into growth again. But we don't have that in our world today. We have 24/7, 365 stress. That means every day you read the paper, you watch the TV, you do whatever you're doing. What are you doing? Releasing stress hormones into your body. From your what? Interpretation. Same body, you could look at something and be in love and have a completely different vision. And all of a sudden you realize you were the master, but we have let other people control our interpretations. And as a result, their interpretations control our lives. And we have been disempowered by that.
Same deal. A bunch of games, 3 levels of rewards. What happens? People offered the medium level of rewards, did no better than people offered the small rewards. But this time, people offered the highest rewards. They did worst of all. In 8 of the 9 tasks we examined across 3 experiments, higher incentives led to worse performance. Is this some kind of touchy-feely socialist conspiracy going on here? No, these are economists from MIT, from Carnegie Mellon, from the University of Chicago. And do you know who sponsored this research? The Federal Reserve Bank of the United States. That's the American experience. Let's go across the pond to the London School of Economics. LSE, London School of Economics, alma mater of 11 Nobel laureates in economics. Training ground for great economic thinkers like George Soros and Friedrich Hayek and Mick Jagger. Just last month, economists at LSE looked at 51 studies of pay-for-performance plans inside of companies. Here's what the economists there said. We find that financial incentives can result in a negative impact on overall performance. There's a mismatch between what science knows and what business does. And what worries me as we stand here in the rubble of the economic collapse is that too many organizations are making their decisions, their policies about talent and people, based on assumptions that are outdated, unexamined, and rooted more in folklore than in science. And if we really want to get out of this economic mess, and if we really want high performance on those definitional tasks of the 21st century, the solution is not to do more of the wrong things, to entice people with a sweeter carrot or threaten them with a sharper stick. We need a whole new approach. The good news about all this is that the scientists who've been studying motivation have given us this new approach. It's an approach built much more around intrinsic motivation, around the desire to do things because they matter, because we like it, because they're interesting, because they're part of something important. And to my mind, that new operating system for our businesses revolves around three elements: autonomy, mastery, and purpose. Autonomy, the urge to direct our own lives. Mastery, the desire to get better and better at something that matters. And purpose, the yearning to do what we do in the service of something larger than ourselves. These are the building blocks of an entirely new operating system for our businesses. I want to talk today only about autonomy. In the 20th century, we came up with this idea of management. Management did not emanate from nature. Okay? Management isn't it's not a tree, it's a television set. Okay? Somebody invented it. And it doesn't mean it's going to work forever. Management is great. Traditional notions of management are great if you want compliance. But if you want engagement, self-direction works better. Let me give you...
An evolutionary biologist at Purdue University named William Muir studied chickens. He was interested in productivity. I think it's something that concerns all of us. But it's easy to measure in chickens because you just count the eggs. He wanted to know what could make his chickens more productive, so he devised a beautiful experiment. Chickens live in groups, so first of all he selected just an average flock, and he let it alone for 6 generations. But then he created a second group of the individually most productive chickens. You could call them super chickens. And he put them together in a super flock, and each generation he selected only the most productive for breeding. After 6 generations had passed, what did he find? Well, the first group, the average group, was doing just fine. They were all plump and fully feathered, and egg production had increased dramatically. What about the second group? Well, all but 3 were dead. They'd pecked the rest to death. The individually productive chickens had only achieved their success by suppressing the productivity of the rest. Now, as I've gone around the world talking about this and telling this story in all sorts of organizations and companies, people have seen the relevance almost instantly, and they come up and they say things to me like, that super flock, that's my company. Or, that's my country. Or, that's my life. All my life I've been told that the way we have to get ahead is to compete. Get into the right school, get into the right job, get to the top. And I've really never found it very inspiring. I've started and run businesses because invention is a joy, and because working alongside brilliant creative people is its own reward. And I've never really felt very motivated by pecking orders or by super chickens or by superstars. But for the past 50 years, we've run most organizations and some societies along the super chicken model. We've thought that success is achieved by picking the superstars, the brightest men or occasionally women in the room, and giving them all the resources and all the power. And the result has been just the same as in William Muir's experiment: aggression, dysfunction, and waste. If the only way the most productive can be successful is by suppressing the productivity of the rest, then we badly need to find a better way to work and a richer way to live. So what is it that makes some groups obviously more successful and more productive than others? Well, that's the question a team at MIT took to research. They brought in hundreds of volunteers, they put them into groups, and they gave them very hard problems to solve. And what happened was exactly what you'd expect, that some groups were very much more successful than others. But what was really interesting was that the high-achieving groups were not those where they had 1 or 2 people with spectacularly high IQ, nor were the most successful groups the ones that had the highest aggregate IQ. Instead, they had 3 characteristics, the really successful teams. First of all, they showed high degrees of social sensitivity to each other. This is measured by something called the reading the mind in the eye test. It's broadly considered a test for empathy, and the groups that scored highly on this did better. Secondly, the successful groups gave roughly equal time to each other, so that no one voice dominated, but neither were there any passengers. And thirdly, the more successful groups had more women in them. Now, was this because women typically score more highly on the reading the mind in the eye test, so you're getting a doubling down on the empathy quotient? Or was it because they brought a more diverse perspective? We don't really know. But the striking thing about this experiment is that it showed what we know, which is some groups do better than others. But what's key to that is their social connectedness to each other. So how does this play out in the real world? Well, it means that what happens between people really counts. Because in groups that are highly attuned and sensitive to each other, ideas can flow and grow, people don't get stuck, they don't waste energy down dead ends. An example. Arup is one of the world's most successful engineering firms, and it was commissioned to build the equestrian center for the Beijing Olympics. Now, this building had to receive 2,500 really highly strung thoroughbred horses that were coming off long-haul flights, highly jet-lagged, not feeling their finest. And the problem the engineer confronted was, what quantity of waste to cater for? Now, you don't get taught this in engineering school, and it's not really the kind of thing you want to get wrong. So he could have spent months talking to vets, doing the research, tweaking the spreadsheet. Instead, he asked for help, and he found someone who had designed the Jockey Club in New York. The problem was solved in less than a day. Arup believes that the culture of helpfulness is central to their success. Now, helpfulness sounds really anemic, but it's absolutely core to successful teams, and it routinely outperforms individual intelligence. Helpfulness means I don't have to know everything. I just have to work among people who are good at getting and giving help. At SAP, they reckon that you can answer any question in 17 minutes. But there isn't a single high-tech company I've worked with that imagines for a moment that this is a technology issue. Because what drives helpfulness is people getting to know each other. Now that sounds so obvious, and we think it'll just happen normally, but it doesn't. When I was running my first software company, I realized that we were getting stuck. There was a lot of friction, but not much else. And I gradually realized that the brilliant creative people that I'd hired didn't know each other. They were so focused on their own individual work, they didn't even know who they were sitting next to. And it was only when I insisted that we stop working and invest time in getting to know each other that we achieved real momentum. Now that was 20 years ago, and now I visit companies that have banned coffee cups at desks because they want people to hang out around the coffee machines and talk to each other. The Swedes even have a special term for this. They call it fika, which means more than a coffee break, it means collective restoration. At IDEX, a company up in Maine, they've created vegetable gardens on campus so that people from different parts of the business can work together and get to know the whole business that way. Have they all gone mad? Quite the opposite. They figured out that when the going gets tough, and it always will get tough if you're doing breakthrough work that really matters, what people need is social support, and they need to know who to ask for help. Companies don't have ideas. Only people do. And what motivates people are the bonds and loyalty and trust they develop between each other. What matters is the mortar, not just the bricks. Now, when you put all of this together, what you get is something called social capital. Social capital is the reliance and interdependency that builds trust. The term comes from sociologists who were studying communities that prove particularly resilient in times of stress. Social capital is what gives companies momentum, and social capital is what makes companies robust. What does this mean in practical terms? It means that time is everything, because social capital compounds with time. So teams that work together longer get better, because it takes time to develop the trust you need for real candor and openness. And time is what builds value. When Alex Pentland suggested to one company that they synchronize coffee breaks so that people would have time to talk to each other, profits went up $15 million and employee satisfaction went up 10%. Not a bad return on social capital, which compounds even as you spend it. Now, this isn't about chumminess, and it's no charter for slackers, because people who work this way tend to be kind of scratchy, impatient, absolutely determined to think for themselves, because that's what their contribution is. Conflict is frequent because candor is safe. And that's how good ideas turn into great ideas. Because no idea is born fully formed. It emerges a little bit as a child is born, kind of messy and confused, but full of possibilities. And it's only through the generous contribution, faith, and challenge that they achieve their potential. And that's what social capital supports. Now, we aren't really used to talking about this, about talent, about creativity in this way. We're used to talking about stars. So I started to wonder, well, if we start working this way, does that mean no more stars? So I went and I sat in on the auditions at the Royal Academy of Dramatic Art in London, and what I saw there really surprised me, because the teachers weren't looking for individual pyrotechnics. They were looking for what happened between the students, because that's where the drama is. And when I talked to producers of hit albums, they said, oh, sure, we have lots of superstars in music. It's just they don't last very long. It's the outstanding collaborators who enjoy the long careers, because bringing out the best in others is how they found the best in themselves. And when I went to visit companies that are renowned for their ingenuity and creativity, I couldn't even see any superstars, because everybody there really mattered. And when I reflected on my own career and the extraordinary people I've had the privilege to work with, I realized how much more we could give each other if we just stopped trying to be super chickens. Once you appreciate truly how social work is, a lot of things have to change. Management by talent contest has routinely pitted employees against each other. Now rivalry has to be replaced by social capital. For decades, we've tried to motivate people with money, even though we've got a vast amount of research that shows that money erodes social connectedness. Now we need to let people motivate each other. And for years, we've thought that leaders were heroic soloists who were expected all by themselves to solve complex problems. Now we need to redefine leadership as an activity in which conditions are created, in which everyone can do their most courageous thinking together. We know that this works. When the Montreal Protocol called for the phasing out of CFCs, the chlorofluorocarbons implicated in the hole in the ozone layer, the risks were immense. CFCs were everywhere, and nobody knew if a substitute could be found. But one team that rose to the challenge adopted 3 key principles. The first was the head of engineering, Frank Maslin, said, there will be no stars in this team. We need everybody. Everybody has a valid perspective. Second, we work to one standard only, the best imaginable. And third, he told his boss, Jeff Tudhope, that he had to butt out because he knew how disruptive power can be. Now, this didn't mean Tudhope did nothing. He gave the team air cover, and he listened to ensure that they honored their principles. And it worked. Ahead of all the other companies tackling this hard problem, this group cracked it first. And to date, the Montreal Protocol is the most successful international environmental agreement ever implemented. There was a lot at stake then, and there's a lot at stake now. And we won't solve our problems if we expect it to be solved by a few supermen or superwomen. Now we need everybody. And because it is only when we accept that everybody has value that we will liberate the energy and imagination and momentum we need to create the best beyond measure. Thank you. If you look at how the neural networks in our brain are formed, they're really built to make our thoughts and our responses much faster and much easier. And what that means is that whenever we encounter something that's familiar, we'll prioritize that information. It will just feel better. It will be conscious faster. And so our minds are kind of built biologically to attract and process and prioritize the stuff we agree with and slow down or forget about the stuff that we don't agree with. And you know, that's why if we have certain political views, we buy certain newspapers, we watch certain news channels, and so on. Actually, to be smart and well-informed and thoughtful, we need to encounter the people, the attitudes, the information, the opinions that we're uncomfortable with. Not necessarily because we're wrong, but because that's what thinking is. It's taking alternative perspectives seriously and having a dialogue with other people and having a dialogue with oneself, which is, you know, what the philosopher Hannah Arendt calls thinking, which is, am I sure about this? How do I know? What's the opposite attitude? What's the contravening information? How can I be certain that my opinions are grounded and sound? And I think it's quite alarming, really, in the United States and also, you know, in Europe, that we have, on the whole, highly polarized media where conflict, contradiction, debate is not really pursued. Instead, we're simply feeding people's established biases and prejudices. That isn't thinking, and it isn't safe.
Extremely well said. And Margaret, you know, you've basically blown my mind about another concept, competition. You have an upcoming book called The Bigger Prize where you examine how damaging competition can be between humans. I mean, once again, flies in the face of everything we've been told. Capitalism based on the foundation of competition that leads to better technology, more prosperity, better rewards.
Yeah.
You disagree. Yeah. Why?
I have to say, this is a really scary book. I mean, it's one thing to stand up and say you don't believe in God. You know, people can kind of tolerate that. Standing up and saying you don't believe in competition, much, much more frightening. But actually, when you think about it, I think we all know it doesn't work. We wouldn't have regulation if it worked. We wouldn't put in place rules and processes to stem the side effects of competition if those side effects didn't exist. So what I've done is I've really looked at, well, if we allow ourselves the dangerous thought that maybe competition doesn't always work and the best doesn't always get to the top, how in fact does it work? And it's quite a challenging and shocking notion that actually the more competitive you make schools, the more you teach kids to cheat at an earlier age. Rush Kidder at the Institute for Ethics estimates that by the time our kids get to college, 95% of them will have cheated on some exam. That's in college. And then we're surprised if they cheat when they get to work. You look at in the field of sports, the higher the stakes, the more the money, the bigger the prizes, the more the doping. The more we use competitions in high stakes games, the more the outcomes are what economists call perverse outcomes, as if, you know, they're not bound to happen, which is to do with cheating, corruption, inequality. This is a real concern because increasingly what I find in governments and in companies, because nobody can make their mind up or because they're not willing to defend their positions, they're saying increasingly, just let the market decide. This is a profound abdication. We can't let markets decide everything because markets get it wrong. They're not fair, they're unequal, people use secret information, there are profound disequilibriums in markets. There is no free market anywhere. So if that's the case, we need to think very, very carefully about how and when and where we use competition to answer the questions that we should be able to answer in more thoughtful ways.
A lot of huge ideas. It's time to start applying them in our lives. Thank you so much, Margaret Heffernan.
So to take a step back and look at one of the most exciting recent trends as applies to infrastructure within the financial sector, there's a latency arms race going on in financial networking. So we have global exchanges scattered around the world, and they all want to talk to each other for arbitrage, for market-making purposes. And so I'll show you two examples here. These are the fastest current network routes from Chicago to New York and New York to London. Chicago to New York is entirely on land. New York to London is almost entirely through the Atlantic Ocean. And if you take a look at the latencies via spread networks and Hibernia Atlantic on the right, these latencies, the round-trip delays for sending a packet round trip, are actually starting to approach the physical limits allowed for photons traveling through optical fibers around geodesics on the Earth's surface. So for the first time, and this is really only happening in the financial sector, the financial sector is pushing the physical limits of information transmission capabilities around the Earth's surface. And I think that opens up some really intriguing opportunities for exploiting position on the Earth's surface. At the same time that latencies are collapsing around the Earth's surface, information generation that's relevant to these market trading and market making activities remains distributed. So these are a couple of my favorite examples. The first one, not terribly widely known. So UBS, as one example of a firm, has recently started mining live satellite photos of retail parking lots to figure out and to try to reverse engineer store traffic. Second example, social media mining for live trading on the markets, mining sentiment, things like this. These are two of many different examples of why the information generation that's critical to making a profit in the markets is probably going to remain geographically distributed for the foreseeable future. At the same time, we want to reduce latencies and reduce spreads. So taking another step back and realizing that we're stuck on the Earth's surface, at least for the moment, in this geographically distributed trading environment, this is what a typical arbitrage transaction looks like if we think of it as an extended space-time event. So you have two locations that are geographically separated, and trading, even if it's pre-coordinated, needs to be to some extent coordinated after the fact, just if for no other reason than to maintain capital requirements and to maintain net neutral positions wherever possible in the case of arbitrage transactions. So this is the way things, for the most part, are done right now. And this is the way they can be done. And so various firms in the financial sector are already doing some approximation of this, but until recently, there was no universal optimal solution that was known for how best to coordinate trading in multiple locations by positioning yourself in between markets. So to be more concrete, let's say you want to perform trading on both New York exchanges and London exchanges. How do you most efficiently do that in today's latency arms race environment? And the answer turns out to be to position yourself somewhere in between, at least in network terms, New York and London, so that while you're not the first person in the world to hear the latest prices coming off a New York exchange or the London exchange, you are the first to hear the correlations between them. And you can think about this as a sort of financial or econophysical analog of reflex arcs in vertebrate biology. So if you touch something, your finger pulls away before your brain feels the pain from the heat. And this is because the pain signal doesn't have to travel all the way to your brain. It just travels to your spine, and your spine sends a signal back to pull your hand back. Same thing here. If there are arbitrage opportunities, rather than requiring a round-trip transaction, it's possible to position a coordination server at a geographically intermediate location that enables trades to be performed more quickly and coordinated more quickly. So this is the subject of a paper I wrote in Physical Review about 1.5 years ago called Relativistic Statistical Arbitrage that solved the universal problem of where to position such coordinating servers. And the answer turns out to be pretty interesting. I'll skip the derivation since we're running short on time, and I'll just skip to the results. This is the answer. Now, this is few provisos. This is one representative solution set with lots of assumptions. The solution that I skipped through is actually far more general, but this gives you a flavor of the sort of treasure map that comes from the universal solution. So many of these locations indicated in with small blue dots here, with the larger red dots representing the 50 or so largest world equities exchanges, happen to fall in network sparse areas, especially oceans. And the general heuristic, again, without going through the derivation, is that optimal locations to position yourself tend to be weighted by volatility for the markets that you're trading on. So, for example, you can see in the North Atlantic, there's this sort of nice highway, again, between the New York region, New York, northern New Jersey, and northern Europe, where many of these most promising locations are for building up perhaps ultimately financial seasteads. What would these look like? These would be platforms. In some cases, this is already being done in the Pacific by reappropriating oil platforms that already have the network connectivity. You put a bunch of servers on these locations, and then the servers are taking advantage of the unique latency correlations that their geography presents them with in order to optimally coordinate high-frequency trading in a variety of markets. So this gives you a rough sense of where these opportunities lie, and if anyone wants to talk offline more about specific locations as a function of network topology, I'm happy to have that discussion. Moreover, again, skipping over a lot of the physics, turns out that it's not just advantageous to position yourself in one location for every pair of markets. It's actually advantageous to position yourself to handle a variety of trading contingencies along entire geodesics connecting those markets.
I'm going to read a little bit from a paper written by Alex Wissner-Gross and Timothy Sullivan called Participatory Telerobotics. I'm going to skip down to the ending discussion. We expect that our participatory telerobotics system, when fully deployed, will have many uses from intelligence and defense to public health, tourism, and retail. Using a one-to-many anonymized interface, intelligence analysts could rapidly mobilize and activate up to thousands of individuals to survey a region, look for suspicious activity, or even silently lead individuals away from danger. Currently, ubiquitous monitoring has high labor and technical costs as well as substantial infrastructure hurdles. With a participatory telerobotics system, the cost would be substantially reduced and might be expanded and contracted at will, leveraging civilians to provide micro aid to the intelligence agencies. Doctors and public health officials could use such a system to rapidly diagnose health-related problems from remote locations and instruct individuals in how to administer topical treatments, take medications, etc. Using the increasingly high-resolution cameras on customer smartphones, doctors could remotely direct patients to move their bodies and zoom in appropriately in order to diagnose and triage visible conditions. Health practitioners could also check in on infirm patients living alone or in groups at a distance. For customers, novel brief tourism experiences might become available, and perhaps even gamified, permitting individuals to briefly activate and direct others so that they can experience new places that they would unlikely or were unable to visit. In addition to virtual tourism, new opportunities open up for remotely inspecting hotels, restaurants, and tourist attractions during trip planning. Similarly, rich experiences also promise to open up for retailers and their customers, enabling the latter to examine products available online or at remote locations in a manner far richer than a 2D image could provide. Similarly, online auction bidders would be able to view products not professionally photographed in 3 dimensions before placing a bid. Of course, emerging mobile device form factors such as heads-up displays will offer major advancements to our participatory telerobotics experience, enabling even more immersive telepresence from a truer visual perspective for all of the above scenarios. With full immersion possible, one might be able to have a tour guide with capabilities of fine remote manipulation of the environment not possible with the present generation telepresence robots, at a fraction of the fixed price. In conclusion, we have presented a novel participatory telerobotic system that generates the existing concept of participatory sensing to include real-time teleportation, teleoperation, and telepresence by treating humans with mobile devices as ad hoc telerobots. Because of its ability to interactively elicit physical knowledge and operations through ad hoc collaboration, we anticipate that our participatory telerobotic system will have immediate applications in intelligence, retail, healthcare, security, and travel industries.
Value. Let's talk them dollars, relative to arbitrage. That's all I'm gonna holler. Because you exist on a unique spot on the earth's surface is the new high frequency quantitative financial purpose. Value. Let's talk that money. Participatory telerobotic survey the land for that honey with easy access to mobile technology, data collection, remuneration, and anthropology. Value. Let's talk that go unique integration of information to be the key to our soul. Every person produces unique and valuable information. I get paid for that issue to change our whole situation. We go hard. On science and mathematics show ourselves with those reactions we never see what happens. It's a battle in consciousness when we play how we play. We actually every day keeping it straight, stepping like the razor blade. Now when 2 people meet, greet out on the street, mutual respect and love like they was blessed from above. They was home optimized, it's epigenetic surprise. Like 2 bodies experiencing one shared emotion while oxytocin is rising. So while you sitting and wish, just crunching and munching, this is the neurogenic, epigenetic, epiphenomenal influence on the societal organism. Our strongest medicine known to man includes FaceTime with family and lending a helping hand, showing love and respect to everyone that you can, like a boucherie, a fédodo, or coupe de man. Tout sweet, tout le monde, tout le même chose. Unity, we I and I in the Tao flow. Slow-mo, robo, aho, YOLO. Human beings survive, don't end up like the dodo. No mistakes. Daily we overcome challenges to release and enhance our character traits. No mistakes. Daily we overcome challenges to release and enhance our character traits. Another reason, you ain't gotta worry, that's an intelligent force erupting like a fury. Another reason, you ain't gotta worry, there's an intelligent force erupting like a fury. They're coming from within, organizing previous controlling constraints, increasing freedom of action. With evolution's great propensity for fault tolerance, using order, disorder, and quasi-order conglomerates to increase utility and range of motion in this petri dish floating in the infinite ocean. To increase utility and range of motion, we a petri dish floating in the infinite ocean. Speaking of the infinite mathematically, and the understanding that only comes about creative consciously, any belief, definition, and system of logic in front of you, y'all be able to transcend and go beyond the proof. Any belief, definition, and system of logic in front of you, y'all be able to transcend and go beyond the proof. The infinite is a live present event. You can reach it with your own 2 cents. The infinite is a live present event. You can reach it with your own 2 cents. It's time we understood biological empathy. Physiologically, when people get together in some symphony, vagal tone synchronizes, oxytocin on the rising, epigenetics surprises, neuroplasticity optimizes. Everyone on planet Earth's been affected by the drama. Releasing allostatic burden load is how to heal the trauma. It's dramatic. Sometimes you gotta spit and vomit to get it, readjust it, and release it. With healing tears, cry a bit. Our optimal psychoneuroimmunological function in demands it. With healing tears, cry a bit. Our optimal psychoneuroimmunological function in demands it.
Don't worry about a thing, 'cause every little thing's gonna be alright. Don't worry about a thing, 'cause every little thing is gonna be alright.
This is the neurogenic, epigenetic, epiphenomenon influence on the societal organism's optimal function. This is the neurogenic, epigenetic, epiphenomenon influence on the societal organism's optimal function. Au revoir.